Yeah, I mean this could be the Ether crew. Who else? Oh,
Oh
maybe
yeah,
Dave.
people will join.
I was People will join. Yeah, I assume Dave will be here at some point. He never misses it.
Who else is into Ether?
Several people.
Absolute.
We've had a bunch of random people pop in
Oh,
during past ones. It kind of just depends who's available, it seems like.
Oh, Noah asked me like, "Hey, do you have any of the Ether Round Table streams?" And I was like, "Of course, my dude. They're all on Alan's channel. His 4, 1, 2, 3, and 4." He was like, "Oh, cool."
nice. That fully loaded resource.
Oh yeah, he
Yeah.
said he was interested in this one.
Yep. 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 Yep.
That's a good little thing. Yeah, I'm working on this right now. I'm gonna try and make a video out of this. Uh, but it's not really like I'm trying to script it and do like a. I'm not gonna like present it. I'm just gonna do like a info video type of thing. Um, but yeah, it's turning out to be a lot more work than I'm ready for.
Did
I
you?
want to try to draw the line between relativity and people becoming nihilistic
Huh?
theories of relativity. And
That's definitely there, dude. Once everything becomes worthless and nothing and meaningless, then the nihilistic lifestyle of "oh, whoa, nothing matters" falls in nicely.
yeah, it's funny. It seems like a lot of if you go to like well, of course, Wikipedia. If you go to the Wikipedia page about the theories of relativity, it's like, and you go to the Wikipedia page about relativism. It acts like they're not the same thing.
Moral relativism definitely not prescribed and filtered from relativity theory. That's already has its Wikipedia disclaimer.
Yeah, it's like, well, it's like, how could you not draw the line that if everything is just based on an observer point of view and everything's relative to that, and there's no universal truth, even if you're not going directly to that point of like pure relativism, you're still obscuring the objective truth. And so, like, you're obscuring a universal truth. So, that alone is going to cause, like, it's going to have psychological impact.
Yep. Dude, it's like a purpose-built fucking luge for moral depravity all the way down to the bottom. Like so they like lube the sides, they get you going. Like the whole heliocentric thing is like, okay, we're gonna teach you that not only is there no God, but you came from nothing. Nothing matters. There's a billion more things like you. Everything is next to you. You mean
Yep.
nothing. You're not special. There's nothing you could do. You're literally a cosmic fart that came out of nothing, a total accident. A monkey fucked a fish and had a retarded squat baby, and that's you. And you're lucky to be alive. And nothing matters. What you should do is do what thou wilt. Do this and have
Yeah.
all your
Yeah.
insanity and hubris and have all these sins and be gay and fucking have pride and all that nonsense. That's how you get there.
Yeah. Perfect. Well said. I'm just going to play that clip and make an animation of it.
nice.
It also limits like the possibilities too, right? Like getting rid of the ether, free energy.
Yeah. I mean, that's huge. Getting rid of the ether, that's like, I mean, basically what that means is that they're separating everything from everything else when you get rid of the ether.
Right?
Ether means everything is connected, everything is part of a fabric.
The energetic background that weaves through everything. Exactly. They take that away, make it a black hole, and actually we revolve around an ever expanding field of nothingness. Like what?
I might have to add that to my notes here.
And that reminds me of that video I stole from Telegram recently. Someone did a nice rendition of Why the Lie, and I capped it. The thumbnail that I use is this, which goes through like the the pathway, right? It's like no globe equals no rotation equals no orbit equals no gravity. Noah asked me equals no heliocentric equals geocentric, no Big Bang, no evolution, no Darwinism. Then it goes all the way through. You're special, and that's the end of the New World Order. I always love that. So it's like, why does it matter? And it's like, oh well, because of all these things. Because it's only everything. It's
Yep.
only the most important thing in the world. What do you mean? Why does it matter? Right? No missing link means you're not random. Means you're unique. Means you're the center of everything. It means intelligent design is real. Means God is real. Means God has created us. Meaning thus there's a creator. Awakening of everyone. End of the New World Order. Yeah, I always like that progression.
It's a
Pretty
noble
straightforward.
ladder, if you will.
Right?
Yeah. Actually, that's a good way to put it. Good phrase.
Good to see silly questions here, man. We were just wondering who would show up to our Ether Bash. Now I know.
Dude, I
You're a
love
true
hanging
G.
out with you guys. I'm not gonna lie, I'm kind of just like a fanboy that's, a gas station attendant, but whatever.
Oh, dude, we're all
Dude,
fanboys.
every group needs a couple good yes men,
Yeah.
I'll be your hype guy.
Dude, the hype man. Gas
It's all
me up,
good,
bro.
man.
Gas me
Fucking
up.
get him, Alan, get him.
Yeah, that's awesome.
Hold me back or whatever. All right. So what do we got? You want to jump into the presentation?
Heck yeah.
All right. I am on stream cam or whatever it's called. Present stream through webcam or whatever.
Showing off his virtual cam because he can.
I mean, it's a nice flex, you know.
Look at all Alan's tags at the bottom, everyone. Look at all the places you can find Alan.
Yep. So you can find me on the Cash Apps, the YouTubes, the Telegrams, the Discords, and the anti-disinformation Telegram also as well. All right. Not to be confused with the other ADL league, which is made and created for an entirely different purpose. All right. So we got Robert Bennett, SciProp, Science Propaganda, Analysis, and Obituary, dude. And he goes over the history of the ether philosophy, the importance of that, and how the rejection of that has led to, relativism, nihilism, and all that kind of stuff. And this acceptance of a completely garbage theory that's, mathematically, intellectually, and philosophically bankrupt on the face of it. All right. So
nice. So this is his actual presentation that we robbed, but we're not going to watch the video of him presenting it. We're just going to do our own thing with it.
Oh, is that what you wanted to do?
I thought that's what we were doing. I don't know. No, I'm fine with stealing the PowerPoint and just ripping through it and doing our own thing. That seems like a good idea.
Yeah, because you can watch that on your own time.
Yeah, I agree. I think it'd be cool to talk about it.
Yeah. All right. Cool.
Go through it.
So classic scientific method, reasoning, and all that. Very cool. What up, David? What up, Mrs. Tribune? How are you guys tonight? Let's see. So he goes into the different models, that are possible. Obviously the heliocentric model and the what's the other one? Tycho's model and the neo-Tychonic model and all that stuff, and the differences between them and all that.
Ptolemaic model is what he had there, though, right? From Ptolemy.
Yeah,
that was neither the neo-Tychonic nor the other one, but okay.
Yeah, it's literally the next slide. My bad.
Okay.
So he's just going over the geocentric models, basically. But thank you. And then he pointed out, so there's this barycenter situation here where they've created a coordinate system for their galactic coordinates or whatever, but it's like completely fictitious. And then it turns out they're not even actually using the quote unquote barycenter. It's still just the Earth. So, GG. I'll have to go back and watch that to kind of get the specifics on it.
Yeah, that was interesting.
But that was like a body bag because it's like they've got this whole barycenter perspective. You know how they're like, oh, from this reference frame. And it's like, buddy, your reference frame's one, it's not even real. And two, when you look at it,
dude,
it's just the Earth again. Like
do you remember the Witsit debate where little J Jump was like, oh, well, actually your answer is that it looks the same from everywhere. And he's like, that is the stupidest thing I've ever heard. And he went on to explain how in his utter ignorance, he had no idea of the preface of the understanding of the statement, right? Like, no, it's because you can't tell. That's why it looks that way. Like, what?
Dude, absolutely. It's actually really funny that that debate was yesterday. Was that yesterday or the day before? But like anyway, that was super recent. Like, and we got a real good glimpse at like hand wave dismissals and like the geocentric frames, fictitious. He debunked it, all this stuff, and then it's like, here we are right back in the center of it. And it's like, you talk to someone who's in the academics and knows, and it's a totally different situation. It's like, yeah, like this, like complete opposite of
that's what them
because that's all the globe has. That's all it's riding on when you really analyze it. Because this is the highest levels of what they got. And we just saw an honest take on what, on how it is. And it's exactly as we've been saying it. And like the layman will often deny that because it's just like
dude, that's why the importance of in the field, right? When talking to the actual intellectuals who are professionals versus the ignorant globe defender tards on the internet, right? Because you get people on modern day debate have been defending the globe for 10 years and know fucking nothing. about any of the model, can't defend the higher
Dude.
like the eccentricities of any of it, right? And then you have the high level academics who, aren't on our side, agree with us on everything. So
yeah, or at least acknowledge that like our interpretation isn't like
right.
isn't off. Like like they might not
Yeah.
agree with it, but it's like they really can't argue it or argue against it in like a way that like, oh, you're completely wrong, because it is open to interpretation. Like we've just been given one interpretation of these things and told that literally time is changing, and that means that, and that's causing the frequency of light to change, and everyone's like, oh, okay, cool. Like people don't really understand like the leadway that's given, that gives them for the coordinate system. Like it just it's nuts. But yeah, so this one was super interesting. Definitely gonna have to go back and fully understand this what was going on with the Berry Center, because like they just don't even, it's not even real. It's literally just the Earth again. Like
I mean, how
something-
could they possibly have the measurement from the sun? Like, it's insane to even like you would have to physically be able to take the measurement from that location, right?
Did they send a probe there? Or
We'll
something?
see.
Isn't that
We'll see.
their
That's
argument.
well, that's where they get into the reifications of all this mathematics, right? Because they're like, well, this Berry Center and all this stuff wouldn't work if it wasn't real, right? But it's literally like, this is how they do it, man.
Mathematical
it's just- it's
reification
just-
extraordinaire.
It's
Yeah.
just disguised. How about the Toby, did you catch that this equation cancels out the mass of the object, so it's literally just kinematics? So when they're like, so
No,
dude, hold on, let me pull this up.
Wait.
This dude,
Is
I
Am I
blew.
literally, are you telling me I'm looking at a magical spell right there?
You're looking at pure magic. So all the
It's the
times we've
unwinding of a magical spell.
all the times we've heard, oh, dude, if the mass of this planet wasn't this, then we couldn't accurately predict the motion of the moons of the planet and all this kind of type stuff, right? So, like, let's take a look under the hood and have Robert explain how it cancels out and doesn't mean
It seems
anything.
like no, that's like a factorial representation of the mathematical representation of covariant scaling, right? So, like, if it's the same at all these, then you can just mathematically invent frameworks that equalize it all the way through.
All right, so check this out.
Well said.
Let me see. Let me make sure this. Oh, you're not going to hear it. Hold on one second. I have to change how I'm sharing on this end so you can hear it.
A dude fully aware of his Discord sharing. Look at that.
Yeah, hell yeah. And then what are we watching on YouTube? I think this is it. Okay, here we go. 2x speed.
Well, maybe it's probably later, so let me
Can you hear that?
postpone that.
Yeah.
Kepler's law,
Cool.
third law, says that the square of the
Nice.
period of the planets is proportional to the cube of the radius. This was discovered pretty long time ago, almost 400 years, more than 400 years. You can actually derive Kepler's third law from Newton's law. The force of gravity on any planet.
Oh,
having a mass
nice.
m,
Oh, watch this, dog.
mass
Watch this
equal
mass.
m is
Watch
the
this
mass of the
mass
sun.
disappear.
They
is equal to
always say
centrifugal
that they
force,
can't do
which is
this.
the mass of the planet times its radius times its angular velocity squared. The angular velocity is 2 pi over t, where t is the period. So you can derive Kepler's law from Newton's law, but notice that the mass of the planet disappears. It cancels out. And this is characteristic of when you have something that is kinematic, something that depends only on empirical observation and doesn't depend on a law of physics.
See ya laser, dude.
Wow.
It
Dude,
doesn't depend on imaginary.
it doesn't depend on mass
Laser.
attracting mass. It's literally just a kinematic description of what's going on in the system. It has no
Toby's
physical
good.
meaning attached to
Sounds
it.
right. Yep.
Toby's gonna have to clip this into
Yeah,
something
I'll
that we
use it
share
for-
forever. Yeah.
Yeah.
This is epic.
Like, dude, just cancels right out, homie. See ya laser.
We all knew that in our within our hearts.
Inherently.
we all knew that.
Inherently, we thought that, yeah, but we
Dude.
had no proof.
We
It's
all
like, well,
we all
they
knew.
could never, because they knew they didn't know. So like obviously they're just making shit up.
Yep. We knew that. We knew inherently they were making shit up, but it's nice to have the mathematical backing to show
Yeah.
everyone how they were making shit up.
Yep.
This is awesome.
Yeah.
This is just a graphic
Magic,
represent.
once the mass disappear.
Poof, it's gone. Look.
Poof. Oh, look, it doesn't matter. Oh, dude, and then when he gets into the two solutions for the perihelion, the two complete solutions, and like the conditions they have to impose on him. I mean, dude, it was like music to my earlobes or whatever, you know. So we're getting into all of it. It was so good.
Presentation of Kepler's law, and it shows that all of the planets, including the Earth as a planet, because this is the heliocentric model, all of them line up in a proportionality where this is the constant of proportionality. And
Yes.
this is proof, allegedly,
That's
that
because
the
they
Earth is just a
derived
planet.
everything from that.
Yeah.
Right? They took the one measurement and they took the form of scaling invariance where they can just make it bigger or smaller, and then all the factors involved would scale coherently, and they built the fucking solar system. Holy
Yeah,
shit.
literally,
Yeah.
too,
How else?
right?
How else
Oh,
would you build the solar system?
Yeah, from optical observations of an assumed circumference. Like, I don't know. There's no other way.
How else? Like, that's how it all started. We all know. They told us that much.
Oh man.
Dude, do we just do a 3-hour watch party on this talk? Like,
Well, it's tough because I've never seen it. We're gonna stop and talk. It'll be
Yeah.
like an 8-hour watch party.
This
No.
has been
we
great.
can't do
Going
that.
through the-
no, I know,
think
but
this-
it's
this
so
is
good though.
perfect.
Like the little synopses.
We go through the presentation and then we just like grab random spots where we remember him
okay.
saying really good
Yeah.
stuff.
Good.
Yep. Let's
Okay.
go back to the
Yeah.
PowerPoint so we don't overdo it. Then.
Good shit. Well, hold on. We'll let him finish out this explanation because you pretty much just summed it up. So yeah, with the scale invariance, with their constant for Earth or gravitational influence, they're good to go. They're all set.
In the sun system. And over here are the details that you can see. You can see that t squared times a cubed, divided by a cubed, is basically a constant, in this case 3.
All right. Very cool. Let's see what else we got. So this was awesome. The parallax stuff. Let's take a look at that real quick. Because when he goes over these angles, so this is the geocentric, the way it would look, and if it should look familiar to this slide. Oh, hold on one second. I have to change the screen share back. Go to webcam or whatever. Or actually, never mind. That's retarded. It's gonna be. Hold on. How should I do this so it's less? It doesn't matter.
Do it better. Fix it.
Yeah. Change screen, full screen. There we go. And channel. Parallax. So yeah, if you remember this little gem. All right, this is. Have you pause. So like what it actually looks like with their 89.999999999999999 degree angles. Turns out, if you just don't assume that you're the thing moving, you can get the angle, the theta is exactly the same for the geocentric coordinate system. So GG.
Yep.
Thank you. Well played.
Like that's inversely proportional again. So look at that. Just like how they backwards engineered the motion of the sky to tell you that the world is spinning actually in the other direction.
Yes, sir. Yeah, dude, that was pure gravy too when he gets into the preferred direction of light. So
well, I'm glad that I feel like he nailed the direction that we inferred. Like from my example of solving the puzzle upside down at the end, you have to flip yourself back. So I'm glad that we were right on that.
Yeah,
honestly,
man, it was.
We were totally guessing.
Yeah, dude, I was with bated breath, bro. So,
Right.
dude, when I saw the slide when I saw this slide, oh, can you see this,
Like,
Shane? Yep. When I saw that, I was like, oh, fuck, man, we made it. We're good. So anyway, here.
To be out on a limb, yeah. All right.
Yeah, I'll do webcam too, so you can see that. But yeah, I did the eyebrow sweat or whatever. I was like, oh, we made it. We're good. So yeah, he goes over this right here, and this was awesome too. So we're on this rotating glob, right? And they're saying, the wind or whatever should be following that glob and stuff, right, in the same direction. But the wind's going in the opposite direction and all that. He basically he described the Bob Winds situation.
Right? I was just thinking that he's not a flat earther.
Dude, literally,
he's keeping the globe model, but he's like it's still all inverse.
Dude, he's never seen this. He's never seen this, I don't think. So when I'm gonna show it to him, but like this is what he was describing during the presentation. Like I won't play the clip back, but he was like, yeah, it's like this. He's like, this makes no sense.
I wonder if he's a private, like a secret flat earther, like, and he just doesn't want to tell people.
No, I don't think so. I think that like he's genuinely stuck in his belief. Like heliocentrism and like globularity is such a facet of people's everything, especially something like they just don't see it, man. Like they could be staring right at it and not see it. I think
the joy he got, or not the joy, but the energy he was talking about. I guess he's just a geocentrist. because he definitely had some enthusiasm talking about the ether wind.
Dude, he's
Yeah.
got the balls to go against mainstream when he thinks he knows he's right, but not the eyes to see from the other group that we're actually right about all the other
He
stuff.
sounds
I
like
think.
he's so close.
Well, let's give him some time. I mean, this is like new stuff
I
to
know,
him
for
too. Because
real.
like I just
I'm
reached
giving him
out.
lots of credit.
Yeah. Like I'm sure, like if he heard the arguments and saw like what
We're all just baffled. Like, if you know all this,
yeah, I
how
know,
come you're
it's-
not where we are?
Yeah,
Right.
yeah, that is what it is. It's just baffling that you could be this far along because you're never gonna find a standard glober that's gonna ever be able to uptake any of this information. Honestly,
Right. And yet here he is.
Yep. All right, and then so we got
This
what's up?
This was the one slide I saw out of context, and I was like, yes, we nailed it. The ether wind one. I was like, all right.
Yeah,
So
yeah.
he says what we said. All right.
Yep. So this slide here, or this graphic here, is actually taken from this PDF. 1 second, I'll pull it up for the full contextual context.
Eastbound
he's
ether
GPS
wind.
pilled as well.
What's that?
He's also GPS pilled, aka he understands.
Oh
the
yeah, dude.
GPS.
Yeah, dude. He worked with Ron Hatch. He goes into, I don't know if you
Oh,
caught
yeah.
it. He gives a Ron Hatch story, and then towards the end, because the GPS is on the second half of his presentation. So yeah, we're definitely going to get into it. And then I'm about to show you this slide right here comes from this paper right here by your boy Paul Marmot, where it's about the preferred direction and stuff. So what they found with their GPS experiments, so-called, is that there's a preferred direction, right? So when they send signals from New York to San Francisco, they're faster going east to west than they are going west to east. They're slower by like the same amount,
Right.
but they would be faster. And then when there's propagation going north and south, it doesn't affect it at all. It's like C remains the same, which is
Right. Crucial.
like,
That's
yeah,
also the
dude.
linearization of the Sagnac effect in 04 is another good supporter of that, dude.
Yep. And
Preferred direction. But you can see how they can take this data and go, okay, actually, the world is spinning the other direction from all the measurements, and they go, oh yeah, oh, that makes sense. It's so smart. Right? And then we're like, no. What if we're not moving, but the ether is moving east all the time? Wouldn't that make everything appear like we're going east to west? Like, oh.
yeah, man, that was pretty trippy too. And then so that also follows the right hand rule with the static charge potential in the sky being high and the surface of the earth being low. So we have, how it's seeking equilibrium, like that downward vector literally creates a magnetic, the toroidal field is rotating east to west. Like it's like without the earth rotating in the opposite direction for some reason, right? We absorb like all the natural stuff with no crazy corrections, no upside down. We're not rotating, there's nobody's antipodal. Like we don't have any crazy stuff going on, and we just absorb the whole thing. Like I love it.
Yep.
Mm-hmm.
It's awesome. So we got it all. And then so this paper's too is really cool because everyone's like, oh, atomic clocks are synced to Einstein's crazy relativity thing that doesn't work only in one experiment for 14 hours. So how they actually do it is they're basically just correcting for the Sagnac effect, but they dress up the equation a little bit. So what Paul Marmot goes over here, I forget the breakdown, but it's like this equation is equal to this equation, which is really just this equation, and it's all just basically accounting for the velocity of the craft, which would be like similar to the Sagnac effect, where you're just accounting for the rotation of the device, whatever the linear velocity is, that speed of the observer, because the clock is on the thing that's moving. It's literally just Sagnacing out, brother. So like no relativistic effects found here, which is great.
So I'm curious about this one because I love the tides.
Yeah.
And I'm curious. He didn't title the slide "Etheric Tides," right? Because he did
I missed when he talked about the tides.
He did the etheric wind, then he did etheric something else, and I'm like, so what was his take on? All right, let's just hear it.
So
we're
gonna hear his take on tides. Yeah, absolutely. And then he had a take on.
Napalm loves tides too. This will be good.
Yeah, we'll get on. Let me gotta change the sharing thing real quick so we can get the audio.
Because I hadn't even considered the effect on tides, like the whole like toroidal breathing effect that we kind of like accept. Is that now an effect of the electrical presence in the etheric wind motion?
I mean, we'll see how it goes.
Well, that's true, but that's not gravity has on the
Or static ether
tides.
instead of gravity.
Another
Pull up your
topic
presentation
that
or your sharing.
is attributed to the position.
What's that?
Keys, restart it. Sorry.
Yeah. The video?
Yeah.
Okay, yeah.
There is no C plus V, there's only a C. Tides, another topic that is attributed to the position of the sun and the moon and the effect it has, their gravity has on the oceans. Well, that's true, but that's not the whole story. What we see over here is a tidal map of the entire Earth, where the red zones indicate places of abnormally high tide. So you see the Bay of Fundy up here in Canada, in the St. Lawrence River. That's red because you have a 50-foot tide there at sometimes. We see that over in Europe, Panama Canal Zone, and over in around Japan. The blue is just the opposite, where there are very low tides. In fact, where you see these white dots, these are called nodes, where there is no tide at all. So there's places in the ocean where the tide doesn't change at all. The level of the water doesn't change, despite what we've been told that the moon, when it's over this spot, it should be attracting the water, and we should have a high tide. So there's something else going on. Yes, there is gravity from the moon and the sun
Static ether.
to a lesser extent. But let's look first at the equatorial bulge.
Yeah, you're saying there's a pressure mediation chain facilitated by the focal point in the sky?
Well, he said he equivocated gravity to static ether, so I think now it's synonymous. Anytime he says gravity, I'm just gonna assume it means static ether.
Yeah. Well, you know what's interesting about this tide situation, real quick. Well, I'll let him finish this out, and then I'll show you something that's crazy.
This diagram shows that if the Earth was spinning, okay, the centrifugal force at the equator would be greater than the poles, and so the water would be thrown out and create a bulge. Okay, so that's the prediction of why there is an equatorial bulge in the heliocentric model. Let's look at that from an ether wind point of view. We have, let's say, the moon in this position, which means the ether is driving it down. So the ether wind, as seen on the Earth, would be pushing the water surface here down because it's directed to get down against the water. On the sides, you would have what is called the Bernoulli effect. When the ether wind passes over the water, Bernoulli's law says that pressure plus mass density over 2 times v squared is a constant. In other words, if the velocity goes up, the pressure goes down. So wherever the pressure goes up, wherever the velocity goes up, the pressure goes down, and the pressure on the water then is released, and you have a higher tide. Not a tide, a global bulge. So the global bulge can be explained by the action of the ether wind down here at the other side, where the ether combines as it circulates around the Earth. Again, you have a 0 point for ether, and you have a low point. Now, as the moon moves around, this bulge changes because the ether direction changes, and that causes the change in the tide just as well as the gravity. So ether plus the tide plus the gravity can explain what we see as the pattern of tides across the globe.
So another backwards engineered but inversed observation mechanically underpinned. Holy shit. Right, so the same effect would just explain inversely, then we'll say, we'll invert the forces.
Yeah, and
so they did that with fucking everything.
Yeah, and that's assuming that there's some sort of bulge, right? But like the pressure mediation mechanic though that he's explaining, and then like if there is some sort of correlation with the focal point of the moon as it moves over through the magnetic field, that polarization that it's causing is affecting the ether or something, and that could be the tides. But I don't think that really explains it that much.
But also what he said made me think of this. Like, so you know how the tidal nodes, they're amphidromic points, they're tied in places of 0 tidal amplitude. There are tidal nodes in like the path of the tropics where the moon passes. So even when the sun, so if they're saying that it's a gravity effect and a pull from the moon, then how come they've never moved any of the tidal node spots? And there's never been a tide in any of those spots, even though the moon passes over it every day,
Right.
And we have extremely dynamic tides all over the world, especially like Funday Bay.
But yeah, that's what this is showing, right? This is the tidal amplitude gradient map, and you can see exactly the places with the highest tides and the low tides. I think you pointed that out.
Yeah, but Funday Bay should have the highest and the lowest if they're going off of this model, right? But it's not, because Funday Bay is in fucking New Brunswick, Canada. And it's like the most dynamic tides in the world. Like from, I can't remember what it is, but it's a lot. Like I want to say like 20 feet.
Well, the one that he started, he said it was 50 feet to tides, right? I think I don't know if he meant that bay. He pointed
Yeah,
to
it
some
was
place in
tides.
Canada, but well, yeah.
Oh, did he? I missed that. I didn't know that he said Canada, because he's probably referencing the same place I'm referencing.
Yeah, that's what I was thinking, but I didn't know the spot. But yeah, he said some bay, and he's like, it has known to have tidal amplitude of 50 feet or more, which is
it's
probably the
Funday
biggest.
Bay.
Yeah.
Do we have a tidal node map on a flat Earth yet?
Oh yeah.
Yeah, Shane's got graphics for it actually.
Hook me up.
All right. Go get it.
Yeah. All right. So let me play the rest of this real quick. I think he's about to wrap up.
Now, ocean ether currents.
Okay.
Here's
Yeah. Ocean ether currents. You want to hear this out real quick?
Yep.
Another area where the mainstream totally ignores the contradictions that they claim for explaining the ocean currents. First, let's look at them. The Gulf Stream should be familiar. It flows from south to north along the east coast of the United States. It divides around Iceland. Some of it goes down past Europe. Other part goes through the North Atlantic Passage, as it were. Most of this is ice covered normally. And then it connects with the Pacific current, which is over here. So there is a connection between the Atlantic and the Pacific through the Arctic region. But that's not what I'm interested in. I'm interested in the prediction
force
of
vector
the
diagram
circulation
we
of the
need to
Gulf.
spin. We got to put this like motion vectors on a flat map to see if that matches like the wind current that we started with. Because I've never seen this or tried it with. Yeah.
Oh, on like Roberto winds or what?
I don't like. So, is this just like a current like vector diagram? What is this called? Do you think? Because we got to find this in a Mercator projection, and then we can spin it to AE.
Yeah, I can ask him.
All right.
So current vector diagram. Dude, you got a vector diagram for those currents,
like,
buddy?
I don't know what you call it, like the current vector diagram.
Full stream. It flows north.
Shit.
Okay. What we're told is that's because of the temperature difference. It's
oh wait, I think we can look at it on here. I think we can look at it on Bob Wynn's Oceans.
Oh, that's cool.
Yeah, then we got your ASCII grid here. I don't know if this is gonna help us.
Oceans. You know, we did oceans. Put the elevation to a level where it makes sense, I guess. Can we not change it? Surface or nothing? Okay.
Yeah.
So this is it. All right.
Not a lot of options.
No, it's not quite what I want because he's got like all the interconnecting tides and like the currents that go through like there's all different names for the currents. I know that they look like splayed out like a snake on the Mercator and the projection that he's looking at. But I think that they would look coherent on an AE map, but I'm just assuming.
It's warmer here near the tropics than it is up here. So the water flows from hot to cold. Okay. Then the water flows back down to the equator. Well, why is that? You told me that it flows from hot to cold. Now it's flowing from cold to hot. And then it returns along apparently a constant temperature, which again contradicts what they claim as the reason for the flow of the ocean currents. Another thing they say is it's the salt density. The salinity of the ocean changes at different points. Okay, same argument. If it's low salinity here and high here, then why does it come back down in the opposite direction? The explanation for this is there are ether currents in the ocean just like there are in the atmosphere. In fact, just as there are in space. You have the same
below,
ether currents
but
all
knock
over
that
the
space
globe,
off.
forming whirlpools, giant whirlpools in the oceans. And none of this is correctly explained by mainstream physics.
But an ether wind with a toroidal vortex looks like it might explain all of it.
Another test for ether.
Yeah, looks pretty good. Looks like it might. Looks like we just might have a shot at explaining it, boys.
Not even that. It's like we built this like puzzle piece and we built all the frame, and they just keep dropping pieces right in the middle. Like, oh, that connects there. Oh, thanks. Didn't have to do any work. That's perfect. That's a perfect fit for us. Thank you.
Yep. All right. So that was tides and currents.
That's awesome. So now I'm gonna call them etheric tidal currents. Etheric tidal currents. That's how I'm gonna explain tides now. When
Yep.
I scoff at solar and lunar tides,
Like,
I'm
oh,
gonna
yeah.
have to point out how they don't pull the tidal amplitude past the infodromic points, even though it's directly under the path of the moon.
Yeah, dude. So check this out. Change.
I also noticed on the last diagram you showed with the magnetic diagram on the Mercator or whatever it was, the AE map, like in Funday Bay, there's a huge magnetic like anomaly right there.
Yep. Yeah, but on my unfinished project there was trying to compare like the magnetic field lines to the tidal nodes to see if the magnetic interference would match like the flower of life pattern. So like, and then connect that with like ley lines, what they say, because that drawing kind of paints the flower of life over flat Earth. But the magnetic, like the infodromic points and the magnetic field lines seem to line up. There's definitely magnetic anomalies where there are high tidal amplitudes.
Is
I
that what
agree.
this video is showing here, right? Do you have both in here? In that one? Did I see the magnetic flux map in here? I thought I did.
Yeah, I think I
Yeah,
have that as a picture. I have that as a picture, I think.
Yeah. It definitely looks to match up. Boom.
Nice little baby picture.
I don't know how that was.
I just tried to zoom in on it, and there's literally no
I don't know what's
discernible
up with that.
information from it. It's a little teaser.
Somebody
Yeah,
downscaled it.
a nice 30 pixels to deal with.
Dude, did you downscale it for Stone Man? So he could.
It's probably Man of Stone, dude. He's probably like, dude, I can't see this. I'm not in North America. Stop being a prick.
He's becoming a meme.
Oh man, funny dude though. Good times.
Back to the PowerPoint.
Absolutely, brother. Let's see where we're. Oh yeah. Wait. So before we move on, I wanted to show you this another paper from our boy Bennett. The geocentric testimony.
Oh, he already published one on tides. My man, I love this guy.
Dude, the geocentric testimony of our tides. What's in this? You know, are we, you know, what are we going to learn here? So what we find out is that there's this thing called what is it called? Solar acceleration. It's like there's like a centrifugal force or whatever. Centrifugal acceleration from the Earth going around the sun, and this would obviously influence the tides. You'll never believe what they don't account for in their math for how they derive the tides using the moon's gravity and whatnot. Right? This agreed upon centrifugal acceleration that is mandatory and agreed upon in the heliocentric model. And they just like,
dude, geokinematics. That's what it's called. I love it. Geokinematics.
Yep, the moon causes no centrifugal acceleration, so no centrifugal accelerations for anyone all around, and it's just all they do it is through the gravitational mathematics, which we just learned is
Dude, now we can scoff and be like, dude, you don't even understand the geokinetics of it.
Yeah, we can just use all this new terminology. Yeah, it's great stuff. So that's pretty cool. And let's see, we'll go on to the presentation. Am I on the right display for you guys? Can you see my main
Nope.
monitor?
Okay, I don't know. Bring up the PowerPoint. There you go. Now we can.
Okay, cool. All right, cool. So we went over this. I'll have to listen to this again. I don't quite remember what this was.
Sounds like more corroborative proof of the ether.
Yeah, exactly, dude. Yeah, your boy Fresnel, more corroborative proof. I forget what this one was. I'll have to go back and listen. So he goes over your boy Yuri Galev from the 2002 measuring the viscosity of the ether, the kinematic viscosity of the ether, and reproducing Miller's work. So he goes over this, and this was awesome. And then also he goes over when you plot that data against sidereal time, it shows like, that's where it's reaching its minimum and maximum dimensions plotted on sidereal time.
Replicated and corroborated in Miller then.
Absolutely, dude. Like,
oh.
They've only ever measured sidereal time. Dude, it was beautiful. Every experiment he goes through where they claim to measure, X, Y, Z, turns out when it's just plotted against sidereal time, it reaches its minimum and maximum dimensions like Come
You
on.
just keep measuring the sky, boys. We keep trying to tell you.
That sky measurement, dude. So there was a really interesting thing here where he's talking about what is it? When they do, spacecraft flybys or something like that, there's some sort of frequency shift that happens that corresponds to an ether wind that they're running into. So like that preferred direction situation, they're running into that. I'll have to go back and listen to this part though. And then he goes over the speeds or whatever that they say that they measured out of them. And then this one was awesome right here. So this is Tor, Colon, and Cahill, and they used the coaxial cable, and this coaxial cable that they laid shows the preferred direction. Like it's in everything, dude. It's like undeniable. Like they just literally just didn't tell everyone, and everyone still
Wait,
pretends.
what is that?
Dude, check this
Yep.
out. Hold on, we'll play it out. We'll let him go over it.
Yeah, that sounds super intriguing.
Yep.
Dude has obviously done his homework and come to all the right conclusions.
Yes.
Save one.
We'll get him though. We'll get him.
All right, a summary of the ether tests. Miller, which I will get to.
It's honestly the only conclusion you can come to with any sort of rigorous like intellectual study, and then we're proving that, right?
I think so. Allegedly.
This is just showing.
Are you able to hear it now?
The results of the test as far as the ether speed that was measured and the direction. So with the MMX, you're going to see that the main feature of that is that they claim that they did not detect an ether, but in fact they did. And Miller showed, this is an experiment done after Michelson and Morley. He found that the speed of the ether detected in his MMX experiment is 374 kilometers per second, and this is the direction in right ascension, 5.2 hours, and declination minus 67. Now this direction is actually
Shane, I need an interpreter.
Eastward, right? Is that what he's saying? He's saying the same thing we're saying.
Who's your eastward directional vector orientation?
Right ascension and declination. Just think that declination is like the mark of the sky, and that has to be time because it goes with the movement of the sky. So time equals movement, right? That's why it's 5.2 hours.
Actually considering that the sun is moving through the galaxy. So this is the direction of the sun or the solar system moving through the galaxy.
It's plotted against their galactic coordinate system. Like it's all good. Just it's all
you
good.
mean the extrapolation of the ecliptic plane out into perpetuity?
Let's just say it involves a barycenter that may or may not exist, or may be the Earth, depending on your level of understanding of mathematics.
Did you say the extrapolation
the direction
of the plane into perpetuity?
That's what they did. That's actually honestly a really elegant way to say it.
Yeah.
Well said.
Some would even say it goes off into the cosmic microwave background. Shane, what are your thoughts on that?
It goes off into the cosmic microwave background radiation.
Yeah,
like
it just
tapers into, or like all at once.
It just intersects with it, eventually in perpetuity or whatever.
All right, so I want to hear this Torrin Cohen.
Yep.
Stars in the stellar sphere. We want that direction, not the direction of the solar system around the Milky Way galaxy. Anyway, that's the only direction that they give. Marinov did an experiment. He found an ether, and he found its speed was 350. He didn't record the direction. There was an experiment done in the Netherlands. The coax cable, I guess a signal goes in. It's a double diameter cable with two conductors. The outside conductor carries the signal in one direction, the inner cable in the other direction. What they found out was as they laid the cable, there was a preferred direction. Oh, stop. There was a preferred direction.
They keep finding it, man.
Again, 5.2 hours, same as up here, and about the same speed.
Dude, so you know how they try to SAGNet correct this situation out of it in GPS by saying that the observer is rotating.
That's always the same direction.
Yeah.
Did you see those readings? That's always the same direction from every test that they've ever taken. So what the fuck?
Except for the satellite.
Well, not only that, but a coaxial cable is like buried in the ground, dog. So like how
it's always lined
the
up with the
Earth
sun.
isn't rotating under the coaxial cable, you know what I'm saying? So like there's a new level of like preferred directionality out of this where it's like oh, you're trying to SAGNet out of it by saying the Earth's rotating under it. How about if it's in the ground, dog?
It's rotating in the ground.
did an analysis of the flyby, of NASA flyby, not NASA, he's in Australia, so I don't know what he used, but he got about the same results. NASA has done analysis of flybys. They find, of course, they don't call it an ether. They just say an anomaly of 420 kilometers per second, and they get about the same same results as the others. Now, we will talk in part 2 about.
And now, obviously, they're not in space and all that shit with their readings, but whatever readings they're publishing from whatever altitude it is, like, it's showing the same result, like, within our system, obviously.
Dude, so what they're showing is that it's always the same direction, but that the propensity is a gradient with altitude, I would think, right? Because that's our argument. And then these are at different altitudes, right? One's at NASA, one's at like high altitude or whatever, one's at low.
Oh, shit.
I would say that the higher ones are faster. Right? So
also probably different latitudes.
So. No, dude.
Or latitudes
dude,
are listed. Never mind.
Dude, so Cahill would be, or I'm sorry, Miller would be, at altitude that was at Mount Wilson, so whatever that is. And then this would be on the ground, the coaxial cable.
So lower.
So
there you go.
So lower, but we'd have to look at the elevation of whatever the Netherlands is to just kind of see. We could see where they laid the cable to kind of get more specifics on that. So if they're like higher or whatever, in regards to where they laid it, like that's why it's increasing right there. And then you got your boy Flyby, where it's like where they're quote unquote in space. So like they're obviously at a higher altitude, and it's just it's increasing at altitude.
Right.
What's the last part there? The minus 67 degrees. What are the degrees?
Right ascension and declination, dude. Right. So
okay, so that's just referring to the actual movement.
Yep. Yep. So that's the direction based.
So the other bit of information that would be, I think, relevant would be what latitude are these all at, right?
Yeah, right. Well, so we don't have enough information to make the deduction that I was making. I was using other inferences that we already have, aka Bob's measurements, interferometry, and velocity, right?
Yeah, it's a really, really good point. I agree.
But it seemed to fit with what we already suspect. So
I would definitely be super curious to also know latitudes.
Yep.
A little bit more information.
Is the microwave radiation that comes to us from outer space. It is detected by satellites, and it's an interesting coincidence, if that's what it is, that the speed of the dipole, that is the biggest part of the microwave background, the part that is linear, that is very close to the speed that the other MMX and ether.
Oh, they did. You weren't joking. They extrapolated the perpetuity all the way up to the micro background.
Little foreshadowing from Alan.
Yeah, you bastard.
There's a quadrupole, an octopole, 16-pole, and so on. And this is not as close as the others, but again, it's only the dipole that's being measured, not the other contributions to the microwave background that I would have liked in order to compare it. So what is the purpose of this chart? To show you how there's already lots of evidence that there is an ether of particular speed that is surrounding the Earth.
Particular direction. Absolutely.
It's coming from a specific direction, although this is not the direction that makes sense in terms of knowing where it comes from. In the
a lot of people think they're on a ball. No, it doesn't make sense that way.
Okay, we've done a lot of ether testing, and Atsukovsky has done.
All right, I'm gonna let it keep playing after this because this is the culmination of Atsukovsky's. He basically like figured out the physicality of what the ether is, based on the experiments that were done and stuff. So at the beginning of this, he gives this really awesome brief on how science works in Russia. So you're never going to believe the process that they use over there. Like, so whenever they examine a new theory or like when they're going to put something forward, he said that they get everyone together, like all the top minds that are like, in support of it, and they battle it out like in a debate. And like the best stuff that does that, that makes it through is like the stuff that they move forward with, and they like actually critique stuff and tear stuff down. So like, remember when I was looking at Galev's ether experiment, and then like, but it was published in that book or whatever, and like part of it, that lady went super hard on covariance or whatever, and just body bagged, like how stupid it is, like that they try and pretend that it's meaningful when it's expanded to everything. So if everything is covariant, then nothing's covariant. you know, and it's
That's
just like,
the theory of relativity thing again.
yeah,
The moral relativism coming in again.
yeah, exactly. So yeah, they go hard on it over there, and this is, you know, this guy put in a ton of work on this, and like, you know, went through all these interferometry things, and you know, actual experiments where they've, you know, measured, you know, whatever the fuck, and this is the deduction of that. So he's going to go over like the density, the pressure, the sound, the sound velocity, and second sound velocity. You have to listen to that again to get that, but yeah, we got the mass, diameter, pressure, like how it affects, like, yeah, check it out.
A lot of analysis of the contribution of all of the Russians. I'm not going to go through all of these, but I'm going to just breeze through the important ones. Okay, so this is parameters of the ether. The first one is density. The density here, I don't know if you can read it, is 10 to the minus 12 kilograms per meter cubed. Now that's an incredibly small density. All right, so this is as thin as you could get, let's say, without being zero. So the ether is very, very thin.
It's
right,
ethereal,
according to
you'd
this
say.
measurement.
Yeah.
Next, we have pressure. The pressure is 1.3 times 10 to the 36 newtons per meter squared, right? What is atmospheric pressure? About 10 to the 5. Okay, so this is 30 factors of 10 bigger than that. So the ether is incredibly thin, but within enormous pressures, far beyond what we experience on Earth. Even at the depth, the bottom of the ocean is nothing like the pressure of the ether. So why don't we all collapse? Well, the same reason you
Ether
don't
is
collapse
nature's
if you
pressure
swim the ocean.
mediation,
Dude,
right?
it's almost as if, you know, there's some sort of harmonic resonant frequency and pressure mediation within that medium that, you know, facilitates all motion.
Dude, ether has to exist for pressure mediation to take place. That's why there's that enormous disparity there. That's interesting.
Yeah, man.
Underwater, because the pressure inside is the same as the pressure outside, and the pressure in space is the same everywhere. The next thing I want to look at, okay, the temperature is less than 10 to the minus 41 Kelvin. Well, that's as close to absolute zero as you can get. That is the coldest possible temperature in the universe. Okay, just a tad above absolute zero. The next one to look at is sound velocity. And I'm going to look at the second one first. There are two velocities that they found. One was the one that traveled at 3 times 10 to the 8th meters per second. That should sound familiar. That's the speed of light. All right, so the ether.
Shoot, hold on, I got distracted. I have to listen to that.
They took it in miles per hour to meters per second. That's how they trick you. They do different units so you don't notice those things.
Hang on, what happened?
Such a big deal.
I was reading something. What happened?
Second velocity of sound is actually just a different unit measurement of the speed of light.
Which completely makes sense when each note in a scale has its own color and its own frequency and its own shape, everything. So yeah.
What the fuck?
And
All right.
eventually, if you keep going up in the frequencies, you end up in the light spectrum.
Yeah, you know what? It doesn't make sense if a bunch of intersecting particles bouncing and intersecting with each other off nothing over infinite distances. Sounds crazy.
Wait. Particles that may or may not be
Intersecting
because they're in a probability cloud distribution where they may or may not collapse or interact or do anything or exist at all. So I don't.
Yay, mainstream. This is what you guys actually believe. Someone put that disclaimer in there. All right, let's roll.
Yeah, man. No probability clouds here, boys. We got straight measurements, allegedly. You know, what it could possibly be.
Okay, just a tad above absolute zero. The next one to look at is sound velocity. And I'm going to look at the second one first. There are two velocities that they found. One was the one that traveled at 3 times 10 to the 8th meters per second. That should sound familiar. That's the speed of light. All right, so the ether that they measured was supporting a sound velocity. That is, the ether itself could move at the speed of light. That was one velocity. In other experiments, they measured a sound velocity at 43 times 10 to the 23, an enormous speed. Okay.
So they're talking about like sound, right?
I think he's talking about the speed of the ether. Like, so if sound can move through ether at that speed, then effectively the ether is moving at that speed. I think that's what he's saying.
Yeah. So that's okay. So two different velocities and one matched what they say is the speed of light. and then the other
Yeah, I
one
don't-
was way
I
faster.
don't know how they got such giant differences, though. I don't know how that works.
For a second. I
If this
Go ahead.
yeah, I think that was what he was saying. That essentially you can do the math to calculate the speed of the ether by the measuring, or maybe I'm thinking of a different part, but he was talking about how you can kind of do the math to deduce the speed of the ether by using the speed of light, and then, I guess you would kind of just have to shoot it in the direction that the ether is going, right?
I don't
Just
know. I'm gonna have
shoot
to,
him,
I'm gonna
shoot him
have
in
to-
there.
I'm gonna have to email him for clarification on that one.
speed of light is 10
Yeah, a
to
lot of.
I might be thinking of a different part of the presentation.
Well, we don't know anything about how those things were measured. He just said they did 2 experiments, and one found it super fast, and one found it the speed of light. We don't know anything else. So
Yeah.
this is 10. This is 10 to the 15. 15 factors of 10 bigger than the speed of light. Now, this would explain the objection of the mainstream. They claim that, okay, if the universe is rotating in a fixed ether, then how do you explain the stars? They should be traveling much faster than the speed of light. Well, the reason that they can travel faster than the speed of light is that the ether in which they move is moving at 10 to the 23 meters per second. All right, so the
There you
claim
go.
that the speed of light is a limit is not true for ether. Light may be limited to c, but the ether apparently has no limit, or if it is 10 to the 23 meters per
Oh.
second.
Oh, that's what he's saying.
All
The
right.
ether has no limit. Wow.
I mean,
So
conceptually, it's just so much more sound than anything in the Einsteinian paradigm.
yes, 100%.
Everything is sound.
Yo, double entendre for you.
Like, it's
So
funny
this-
because, yeah, I feel like he's saying so much that we've, like, kind of come to assume ourselves. But
Yep.
he's in, like, a different paradigm, but
Yep.
it's just still a better paradigm.
Dynamical viscosity. I want to see what he says about that.
addresses the objection that the stars could not possibly move beyond the speed of light. Well, they can, because the ether in which they're embedded is moving at that speed. Now, what is the temperature? Should I do that? Viscosity is interesting. The kinematic
Come on.
viscosity is 10 to the 9. That means if you try to stir the ether, there's a lot of resistance, okay? 10 to the 9. Dynamical
Kinematic
viscosity means,
viscosity.
though, that when it moves, it's got 10 to the minus 2 resistance, which is very low.
Oh.
Okay, so if you try to stir it,
So
it puts
the
up a lot of
difference
resistance.
between the ether at rest and the ether in motion. What else do we know about that, boys?
Well, no, I have no idea. Like, I'd have to look at where I have to look at how this was
Wizard
derived.
talks
and
about it
what
all the
that-
time. He's like, electrostatics is the ether under torsion, and the ether under stress.
Yeah,
That's the
exactly.
force of
It's a wave.
electrostatics coming up.
It's a wave. When it's
But he-
at rest and when it's not, for a wave to occur, those things.
Well,
have to
so
occur.
viscosity is like thickness and friction, and he says kinematically. So like when it's still and you try to move it, it resists like a force of nature. Yet when it's in motion, it moves with what, agility and grace, like
Yeah.
beyond what you'd expect. That's crazy.
But
Yeah,
once
that is.
it's moving, it doesn't rub against other parts of the ether and slow down.
No friction.
Well, it does,
right.
but very little. The rest of the stuff we can ignore. Now, Aether has a model for ether, which consists of 2 states. You can have a free ether or unbound, which means that it is far out in space, right? It's not near any mass. There's no electric charge around. It's free. He claims that there is also a bound state of ether in which if the ether starts to rotate and forms, let's say, a ball, a globe, or it could form a donut, a torus, or any other shape that's consistent with rotation. He said this bound state he called AMER, A-M-E-R, and it has the property that each one of these little particles has a mass of, hold on, 10 to the minus 114 kilograms. Okay, so that's a 1 followed by
Your
114
particles-
zeros divided into 1.
Yeah. So what he's describing here with these AMERs, right? So, you know, in quantum physics where they're like, hey, there's this like particle that may or may not exist, who knows, right? But it's some sort of modality of the ether based on a fluctuating charge
Oh.
potential. So, but what that means is there's a little tiny vortex that's created. And what he's saying, what this mass is, what this the length of this mass is, it's just a little tiny vortex. So when you get into Maxwell's equations with what's his name, Hertz's modifications to that so that they could describe the central centripetal convergence and divergence of the toroidal field. When they brought that in, they were able to describe a vortex properly. And it turns out a vortex, because the ether is like a gas or whatever, with this like thin viscosity and all that shit. A gas in a vortexual motion is the only thing that could form a physical particle, like what they're saying is like a physical particle, right? So like as it's manifesting, as that energy fluctuation or motion or whatever is going through it, it's like physically manifesting like that, the modality of the ether is changing, right, based on motion.
So vortex math. Yeah, I was just gonna say that. Yeah, exactly that. Right, 369 Tesla vortex math.
No. This is
well, watch.
Yeah. Well, like I don't know about the 369 vortex math thing, but
it forms this. You see?
Oh, okay.
Yep.
There you go.
I've seen that on
nice example.
Damn. Okay.
Usually when they show vortex math, they show that 2D one. This is a much better demonstration.
Yep, for what we're trying to see, it's exactly what I wanted to show, right? So it's a extrapolated 3D model, right, of the vortex math that goes back and forth. It's essentially like this thing, like extrapolated.
Marco Rodin.
This is what Tesla said.
Yeah,
was
exactly.
the universe.
Exactly, but he's talking about it in a slightly different nature, I think.
Cool.
Yeah, slightly different, but same shape.
Yep,
same
that's
shape.
The shape the map describes.
Yep, absolutely, dude. That's badass. So, yeah, that's what Atsutovsky was talking about in his book. That's what he was describing with that. So, like when there's motion and like the ether is like manifesting into a particle or whatever, it's starting from this vortexual motion described, through the centripetal convergence and divergence of Maxwell's equations. All right, cool.
All right, so an incredibly small mass. And the theory is that these masses can coalesce, can combine to form particles that we're familiar with, like electrons, protons, neutrons, and all of the particles that have been identified.
So again, just a change in the field doesn't necessarily have to be like an electron that you could like hit a baseball bat and like knock an electron out of the park or something like that, right? But what's creating a change in the field is a vortex is forming based on excitation within the medium.
By physics in the particle smashers. Okay, how small are they? Well, the diameter is 10 to the minus 45 meters. Incredibly small. Well, if they're incredibly small and very small mass, the number in a unit of the volume must be enormous, and it is. It's 10 to the, looks like 102. All right, again, 10 with 102 zeros. So there's a fantastic number of these AMERs in this model that is in every cubic meter of space. The rest of the stuff, I don't think.
What I think that is, dude, is he's just taking like, hey, in quantum physics, they're saying this for their heliocentric model based in nonsense pseudoscience. Here's the actual real-time interpretation of that, extrapolation. Yeah, so I think he's making like the geocentric comparison for the new nonsense that you're describing with the tiny, right?
Yeah, so that's what Atsukovsky's book was about. Like, so he's going through like actual experiments where they have like an actual measurement of something, and they can extrapolate, information from it that's not based on the bending and warping of space-time and fictitious stuff like that. And they just like re-examined it and just applied like what could actually be going on with it. And this is where all this comes. This is like the end result of what he culminated out of that.
That's cool. I didn't read any of that. I'm glad that I was able to discern that from the bottom of a chart.
Yeah, absolutely, bro. Dude, I'm glad I read what I read out of that book, because it all came like it was all related. It was all super related to this, and that's actually how we found my YouTube channel. So shout out to Atsukovsky and his research, bro.
Nice.
I know, because I have the only English copy of the book, and I translated it with AI.
Shout out Alan's presentation, Aether Round Table number 4. Yeah, that was 4.
Nice.
Okay, we get to the MMX. First.
Oh, okay.
Oh, this is where you like double body bags interferometry.
Yeah, so then he just starts sweeping up interferometry, dude. So
Oh, it
But
was
we've
so good, man.
we've already done that extensively, though. I feel.
Yes, we have, but he had a few moments in there where it's like, ooh, he put that in a way that none of us have ever put that. That was like really well put.
All right, let's see if we can find and hone in on those instances by glancing at the
Well, I
PowerPoint
mean, we
and
don't have
jogging your
to.
memory.
I will be spending a lot of time doing that later for sure too.
yeah, no, you should definitely give it a solid rewatch. Like, you know,
Yeah, I haven't even seen it, dude. I'm gonna watch it in its entirety for sure.
yeah, definitely. But yeah, I don't remember off the top of my head for some of it. Oh yeah, when he broke this down about the speed of light. So when people are like, "Oh no, it's a no result, bro." So these bars here are where they measured C at. And this red line here is what C should have been
We can't see anything, dude. We're looking at
oh
YouTube.
oh badass. 1 second. All right.
Oh, if you go to his
There you go.
camera, he has it all on his virtual camera.
Oh yeah, dude. Just do that so I don't
I
have
wasn't
to
watching.
swap. You guys swap. Nah, I'm good. I'll swap for you guys. It's okay. So yeah, right here we have this red line is the speed of light, what it should be if if the Michelson-Morley was an actual null result. And here we have a measurement that's above the speed of light, a measurement that's above. Oops. And then these bars right here are the standard deviations or whatever. Or statistical what do you call it? Toby, what's the word?
Sorry, I got a message.
Cool. All right. So we
I saw
got
something shiny.
we got Miller and Mount Wilson with this sidereal plotting the data against sidereal time, showing the minimum and maximum
That
dimensions.
is a wonderful way to represent plotting and matching against sidereal time. It's like, watch, as the sun comes and goes, the measurement goes up and down. Do you guys see that? Look at that.
Yeah, that's
It's
fantastic.
like, this is a great way to visualize it.
Yep.
Because they're like, look, I'm measuring the speed of the Earth. They're like, yeah, actually, you're measuring the sky. See how it lines up perfectly with the sky and the stuff in the sky?
GG, man. That's what's up. And then so this guy, Dim Jim Nemov, did a thing, and I'll have to re-listen to this part. I'm not exactly sure what was going on here, but he did some stuff. And oh yeah. So the amplitude of so you know when they do these experiments in a vacuum, the amplitude or whatever of the light wave or whatever gets messed with. So the fringe shift pattern, it affects the readings, like you know how Miller figured out all this stuff. So like he goes over and breaks down this experiment where he shows that when they do these experiments in a vacuum, it affects the amplitude somehow. I forget the significance of it, but it basically messes with the readings or whatever. So this is, I'll have to go back and listen. Actually, let's just listen to it. Fuck it. That's what we're here for, right? Do it.
Yeah.
We'll do it live.
Fuck it, we're doing it live.
Yeah.
Well, fuck it, we'll do it live.
Absolutely. Yeah. Because some of the stuff I was like reading chat, I got that short attention span sometimes. So I was tuned out a little bit on some stuff, but
An ether wind that's coming from the stars.
Volume.
All right, here's the
We need
dim-
volume now.
Oh, I got you. Got you. I had to switch. My bad. I got lost in the ether sauce. You should be good to go.
It was one of the etheric tides probably caught you.
Dude, I got caught with that gravity that disappeared in the equation when I simplified it.
The static ether got caught with the etheric tidal forces that wrapped up.
Dude, my pressure just got mediated.
Janov test. And this
Do we all agree that we should call that farting now? Like when we fart, we're like, I'm about to mediate this pressure or whatever. Like I feel like we should incorporate that into
The etheric
lingo.
toroidal medial pressure mediation is about to happen. Yeah.
Can you feel the pressure mediation coming
Yeah.
out of my black hole?
Things are about to
There you
get
go.
real toroidal around here.
Black hole sun. There it is.
So what's up? All right, here we go.
was done only 13 years ago. As I said, when you have a vacuum, that is when the index of refraction is 1, he found that the light wave amplitude is 0. And so the speed of light is measured to be c. If n is greater than 1, if you have some material along the path of the light, then he measured that the speed of light is c plus v. And the speed of the of the ether, he measures between 140 to 480 meters per second. Okay, remember the slide where I showed you the different measurements of the speed of light? Well, they were in the middle of this range. Again, the amplitude is 0 as n equals 1. That's a vacuum. Very interesting is this. He found that there were 2 values of n that produce 0 amplitude. When you have an index of refraction that equals the square root of 2, you also get 0 amplitude. It's the same as if you were at a vacuum. This really requires an explanation. Here's the experiment that shows this. What he's plotting here is the...
Thoughts on that, Shane?
I did the thing that you said you did.
Respect, bro. So
was
there's
like,
a
fuck,
there's
I
a
was in
refractive
comments.
index that when it meets the square root of 2 or whatever it was, it cancels out like the speed of light. Like it cancels out the ether effect. Sorry. So just play it back a second.
Produce
It's,
zero
it's crazy.
Right.
Yeah, dude. Dude, I know it's like
How
I
is it
know.
measuring
Dude,
it?
hold on, Shane. Shane, let me hold your hand, dog. So
I need it too. I did the same thing too.
Same
Sorry,
thing.
dude.
No, you're straight. Same thing happened to me because it's like, what the hell is all this? A lot of stuff on the screen, and then there's also stuff on my other monitor. But just focus in, dog. Focus in. Let's do it. We can figure this out. There's definitely some gravy here. All right, we're going in. Oh.
Okay. Remember the slide where I showed you the different measurements of the speed of light? Well, they were in the middle of this range. Again, the amplitude is 0 as n equals 1. That's a vacuum. Very interesting is this. He found that there were 2 values of n that produce 0 amplitude. When you have an index of refraction that equals the square root of 2, you also get 0 amplitude. That's
Why? I don't know the mathematical significance of the square root of 2.
Well,
I think it's just that's where it happens to happen.
Yeah, just the fact that it
Oh,
happens.
so that's the oscillation period, which forms like the sine wave. Those are like that's the periodicity of it. Then that's what it means.
Yeah.
Oh, see, I just understood it real quick. Okay.
Yeah.
So that's interesting.
Re-understand it again.
He's talking about the periodicity. You remember that time? So like the max and the low, that would determine like the amplitude of a wave. The sine wave, you know how it goes up a certain degree and then goes down that exact amount?
Right.
That's what he means. That's what he's measured. So he got the n values are the top and the bottom values of the max and the min of that amplitude.
Yeah, and if it's in a vacuum, it's 0. And then if it's in a medium that has a refractive index of a square root of 2, then
Where
it's
does the
also
amplitude
0.
play into this? Where does the amplitude play into the speed of light?
Well, no, the way that the graph I'm looking at there, if you envision, he found that the end values are like opposite ends of the spectrum, right? So one would be the top and one would be the bottom. And then if you like graphed out,
okay,
yeah, those, I don't know.
But so then what would be the end result to because we're talking about a range of the speed of light, right?
Yeah, I think so.
So I wonder how big of so 140 to 480. Yeah, no ether though.
the same as if you were at a vacuum. This really requires an explanation.
Okay, so he doesn't know either. Okay, thank God. Dude, I don't fucking know.
Yeah, that's dude. Okay,
I
was like,
all right.
And you're talking about like, yeah, so you have an ether, but you're also just you're talking about a vacuum versus a non-vacuum, right? It's simple. It's just the amount of medium that the light's moving through. I mean, even within ether, you'd have, I guess you'd be moving through more perturbances. And so when you're moving through more perturbances, it would nullify or it would change the wave, the speed that the wave moves at, that propagates at.
Dude, I just have like one question. What's the difference between a perturbance and a perturbation?
A who? What'd you say about my mom?
Sophie, what did you call it?
Perturberance.
Perturberance. Is that a thing? I don't know. I don't think that's a word.
Yeah, dude, my dude just made up a word on the spot.
Right, Wither says it all the time. He loves that word. That word doesn't even need to be replaced. It's a really good word. Perturbation.
Can I just say something real quick? So I think what he's talking about here is he's talking about the the wavelengths of light, right? Yep.
Yes.
So your amplitude, he's talking about up at the top, your amplitude. So your amplitude of the quote unquote light wave is at 0. When he says he's talking about the refractive index. So when the refractive index is 1, which is in a vacuum. So the refractive index of a vacuum is 1. So you get 0 amplitude. So you have no like perturbation. You just have a straight line energetic pulse, right? Straight through.
Yeah. Okay. So because it's not.
Okay.
So
Okay.
yeah,
Okay.
and he's saying,
I see you over there.
and so then he's saying that any refractive index that is the square root of 2 also mimics the same as a vacuum, meaning you have no amplitude, but the energy is still quote unquote there, quote unquote traveling with no wave motion. It's kind of like straight line.
Right. So then you assume that between those two values, there's oscillation and non-zero, right? So
Correct.
that's when you get the amplitude. Yeah, that's kind of what I thought. That's a really fucking elevated, elegant way to say it. I'm glad you're here, Napalm.
Dude, Napalm, congratulations on the new short that's going to be coming out from Toby here, where you explain this, what's going on here. Thank you.
Yeah, sorry. I just caught that. I'm in the middle of doing a bunch of crap around the house, and I was listening, and I looked
you're
into
good.
that, and I was like, I'm pretty sure it was talking about the refractive index. So
dude, that's a good way to explain it. Excellent.
I'm going to go back on mute and clean my house. Join the convoy, boys.
Thank you. And Glenn Salch wanted to point out that the N1 stuff is plotted against a perfect vacuum too. So like, assuming that there's nothing for the light wave to vibrate in, right? So like you get no amplitude, and then when you're going through a medium, it's still sending the energy through it, even though it's not vibrating enough to create, whatever spectrum. You know what I'm saying?
Yep, I know what you're saying.
Yes.
Dude, I feel like when he gave this presentation, were you even there yet? Or was this like with him and Whitsitt alone?
Okay, so what happened was about 20 minutes into going live. Okay, how it was gonna go in, Whitsitt brought him in, introduced him and stuff, and I was backstage, and when he got to the part where he was going to like in between slides and ask if we had questions, that's when we were gonna jump in and all be on cam together and do like back and forth or whatever.
I see.
But as soon as that happened, my internet disconnected, and then
you motherfucker.
Yeah, and then but it wasn't my fault. So like since I moved, my internet's been fine. There was like some construction down there. There was some construction down the road, and they just iced the internet for like 3 hours. So it was cool. And
well, your connection does seem way better now, though.
Oh, dude,
you mentioned that.
Dude, the box is like right outside. Like it's awesome. So yeah,
so I was trying to figure out like when he was dropping this awesome gravy with no interruptions. Like there's so many opportunities. Like us just watching it now, we had so much opportunity to add context and value to it that I feel like Whitsitt had the opportunity as well and just didn't do it. Or
so it gets worse, right? So when you're backstage and you have somebody presenting or whatever, when you're the host and you backstage to get out of the scene so that it just shows him, so it just looks aesthetically pleasing, for the audience. You don't have any mic input. So Whitsitt was trying to chime in, but Robert couldn't hear it.
He's muting himself.
Yeah, essentially. So Robert thought that it was like, okay, well, no feedback, no going. It's like maybe just going to. Dude. So he just plowed through. So after a couple of
looks like
so after a couple of times where Whitsitt missed it because of that, he just started plowing through and stopped asking if there was any questions because he just was like, okay, I must just be plowing too hard and no one gets it, so I just got to run through it, which I definitely sympathize with because it definitely happens.
Yeah.
Out there in the streets and like
That's funny.
So yeah, Whitsitt was supposed to be wingman, but he messed it up a couple of times, and then Robert was like, all right, well, I guess we just got to ride this horse out or whatever. So.
It's probably better because that was still a long stream and he got the whole thing out and now we can take it apart later, I guess. Dude, so it is what it is.
So no, it actually worked out perfect because he hit the 3-hour mark right at 45 slides, which is where he had it split. And then like if we had interjected and gone any longer for any slide, like it would have messed up everything.
That's what I mean.
Yeah, so it actually worked out perfect. There was a perfect amount of back and forth. But yeah, at some point in here, I jump in. My internet comes back and I'm like, All right, boys. Yeah, right around 2 hours. I do eventually jump in, and then we start going because
Dropping it up.
yeah, Witsit was like, he was like, dude, he's just powering through. I don't know when to jump in. And I'm like, yeah, dude, like he's a loose train right now. Like, you just gotta jump in. So
All right, that's
so
great. That's exactly what it felt and looked like without knowing any of that.
yeah,
Okay,
on the fly, it all
good.
turned out great, and the end result is fantastic. So
Definitely.
yep.
That shows this. What he's plotting here is the 1 minus n squared. So at 0, which is vacuum, he gets 0 fringe shift. Then it increases to about 0.5 or 0.4. And you would expect that it would continue to increase because as the density of the material increases, you would expect that the light speed would reduce. But instead, it goes back to 1, as this path shows. So when you use a medium, which is a vacuum, or one which has square root of 2, which is 1.414, you will get 0 amplitude. Again, what does he get? The sidereal time fluctuation. Everyone is getting this. Everyone is getting sidereal time matching.
Dude, it's a
Imagine
sidereal.
that.
It's a
Dude,
sidereal blowout, man. Like they
They
just
keep
can't get
trying to
away from it.
pretend they're measuring the ground by measuring the sky, except every time they make measurements, they coincide with things in the sky, and they just like brush it off. Like, nah, it's definitely the ground moving the other way, guys.
Dude, this is why they had to go with relativity, guys. The only way to explain this, to get out of this, was to length contract and time dilate. To invent,
We had to invent branches of physics and
yeah,
scientific discovery to describe the fucking nonsensical way we circumvented this mathematically. Oh my god.
Dude, it's the only
They didn't
way.
even have the language to describe the absurdity that they had to commit to fucking explain that shit away.
It's the only way they could do it, man. And they only do it for that one experiment, and then they just use the other ether technology for inertial navigation systems and whatnot, like just completely utilizing the fact that the earth is stationary and that there's an ether wind. What's that?
Which device was this?
Inertial navigation systems. So like, the thing that Bob had, like the $20,000 to $40,000 systems, like those gyroscopes. They're called inertial navigation systems.
And how many measurements was it?
What's that?
How many measurements are plotted on this? Like, I guess to get this, the fringe shift change that they show here.
Oh, I don't know. I'm not familiar with this one. I have the paper, but I haven't read it. He's just kind of going over it. I don't know how many measurements are.
It's just yet another one.
Yeah.
Yeah, he was piling on the Miller corroboration of different measurements at altitude, different variations. He was going hard on it, and then we just kind of zoned out because it was like 6 or 7 fucking corroborative analyses that all agreed.
Yep.
Insane.
The variation of the ether wind. Now, Michelson-Gale did an experiment in 1925. They intended to measure the rotation of the Earth, so they're obviously heliocentrists. They believe that that was the mainstream belief.
He says it with a slight sneer.
Yeah, he's like, ha,
heliocentrists.
He's like, ha, they believe in a barycenter. That's really just the Earth. GG. So what's awesome about? So what's really cool then about what's that book? The supplemental ephemeris thing that Absolute found.
Yeah.
Like, so all the references that they make to the barycenter and how that's proof of heliocentrism and how, dude, it's actually just the Earth. Like, I can't wait to go back and dissect that. We're actually going to do that right after this ether thing real quick.
Nice.
Set up the Sagnac type experiment, which I showed you before. Light comes in here. It's split up into 2 half beams. They go in opposite directions along a length of latitude on the Earth. That is right here and right here. And they come back down. And again, if there's an interference pattern, it shows that there's a difference in the speed up here and down here. This was done in an Illinois cornfield. And it's about the pipe that they used for conducting the light beam is shown here. It was obviously done in winter. It produced a difference in the fringe shift for the following reason. at different latitudes, the ether speed changes. It's greatest at the equator, and it's 0 at the poles. So if you go along this path, which is L1 here, the ether speed would be greater than it is here. They're in the same direction, but their speed is different at different latitudes. And this was big enough. This 1.25 mile long pipe was long enough for them to detect the difference in the speed of ether at the lower latitude versus the higher latitude. And what did they find? Well, basically the same as all the others did.
Oh, variance with
There was
altitude. No way.
Shift in the ether, and that the rotation
There he
of the
is.
ether was interpreted as the rotation of the
Dude,
Earth.
that's what I was like. All right, we gotta
Sorry
step
about that.
in,
My internet
dog.
disconnected.
And
And,
Alan
wasn't able
enters
to
the
jump in, but I was
chat.
watching live for a little bit on my phone.
Boom.
But yeah, so the importance of the sidereal
Oh,
measurements
and now
of the
Winston
parameters.
comes
So they have
in.
different types of configurations for the ether parameters.
I had to kick the door in, dog. It's like 1 second.
First, they got the classic
Just
Michelson-Morley, the orthogonal setup, the right angle. Then
Right.
they have a closed circuit with a sag neck. Now, in Michelson-Gale, same situation. It's a closed circuit loop. They're all measuring the same fluctuations that, when plotted against sidereal time with no relativistic corrections, they have this thing that they can plot out that matches like the movement of the sky, so to speak. And they've completely disregarded that in certain situations, or applied corrections after the fact to say that this is actually movement of the Earth around the sun. They've never, just to be clear, they've never ever
My
once
boy,
measured the movement
fucking
or a
nailing
fringe
it.
pattern that would correspond to the movement of the sun. Like it's
Kick
not
it
even
in the
close.
Well,
door for
they don't
real.
find it.
Threw a fucking flashbang in, dog.
It's fucking clear.
Oh shit.
In other words, there isn't an ether wind well, there is one, but it's very low level. And actually, I'll discuss why that's true in part 2.
Dude, his
Okay.
fucking mic
But,
sounds terrible. You're right.
Yeah, they're ignoring all of these ether experiments that I'm.
I'll do. Wait till we get him to fix it live.
Oh.
Sorry about that.
Yeah, that's gonna be the only. That's the only problem with making shorts of this guy is his audio is terrible.
describing. And I pointed out that that's one of the tactics for a dissident to overcome, is they just ignore what is blatant proof that there is
Wait,
something
who's-
going on that they haven't explained.
Who's the
They also make fun-
dissident? Heliocentrist? The other dissident in this
No,
example, then?
No,
Or are we?
we are. He's describing
Oh.
that their tactic is to just ignore the measurements that don't prove the model, and then only accept the ones that do. Just kind of ignore.
So what's his position though? He's a geocentrist
yeah,
who believes in
Geocentric
etheric
models.
wind and static ether instead of gravity.
yeah,
But also space and stars are real
is-
and parallax.
yeah. I mean, he talks
Okay.
about the moon landing and
What?
doing experiments on the
Aw.
moon later on. I mean, dude,
No.
bro,
He did. I missed that. That's
Yeah.
hilarious.
Oh,
Bro, he's-
okay. That's all right. He's an old guy.
Yeah,
that one's probably beaten into him.
dude. I
That's
was,
probably tough.
yeah. It's like,
He's an old guy, so he,
Yeah, you can't.
Kubrick can
Dude, it's
pull it
like-
over on him.
Like I could never have gotten my grandma to not be racist, right? Like it was like inherently part of her.
Right.
You grew up with it. You couldn't train her out of it, no matter what you said. I
Dude.
feel like him and the moon landing would have a similar relationship.
dude, exactly, man. And people in the chat were like, freaking out when he was like interpreting, the movement of what looks like, how Jupiter looks like it has, what is it called? Crosswinds going different directions with the streams or whatever. And he was like interpreting that through like different ether velocities going in different directions and stuff. And it's like, that's cool, man. Like whatever. But like people,
Yeah, man.
But people were like, "You're like, why? Like, dude, just relax, man. It's all gravy. Like he's got his
Dude,
own
yeah, honestly,
thing going on. Like it
I-
doesn't matter at all. Like
I
it's
love this
fine.
guy, dude.
Dude, yeah,
Because
he's,
Xavier says we got to excuse a little bit of boomerisms, and he's 100% right. So let's just
Exactly.
roll.
exactly, dude. He's straight homie, dude. There's nothing here that's
He's
Well,
just
it's fine.
he's
It's a
just
no
he's
result.
just trained to be flat prejudice.
Yeah, they all are though. It's
Well, it
fine.
isn't a no result.
We forgive you.
None of them ever found 0.
Yeah, it's all good.
Yeah.
They always found a fringe shift.
Yeah,
So to
absolutely.
clarify some things for everyone, when we're talking about
Hey,
C,
there he
which
is
the
on his own
velocity of light,
show.
Maxwell's equations actually use permittivity and permeability of a vacuum, right? So
Right.
impedance of free space, which would be ether. So actually to even formulate that value in the first place, it uses the fact that vacuum has some form of impedance, right? And
Right.
then so they just hijack the ether for all of this and then throw it away, discard it once they get the results. Something else I found interesting is when you were showing the chart of basically the characteristics, and you said that
Now he's on.
it's very
Now he's
tenuous.
in. Okay.
Now he's in.
That
You
matches
just
what
had to get
Tesla
him
said, right? He
going,
said it has a
dude.
tenuity beyond conception.
Can't believe you let him go.
Right, so the data is matching up, and then to clarify for everyone, what these tests are showing is that consistently there's a preferred direction when it comes to the propagation of light, whether that be visible or non-visible light. There's a propagation rate or the preferred direction of the propagation rate, and it corresponds to latitude and altitude. Is that correct?
Right. And the other important thing is that it depends on the motion of the stars, or the apparent motion of the stars, and the Earth. It doesn't depend on the motion of the sun. which it would if this were a heliocentric model, right? The sun being the center, then that would be the source of the ether. The ether would be rotating around the sun. It doesn't. It rotates around the stars.
And like basically like a vortex, it seems, right? I'm
Yeah.
curious what you think about this. I don't hear many people talk about this.
Around the
So they
stars.
assumed the 30 kilometers per second in Michelson-Morley, like you just covered. They didn't get that. And then of course that's where they came up with what you talked about in the beginning, the length contraction and all these other excuses. But what is your take on the fact that shouldn't the propagation rate or the fringe shift also show the alleged motion of the solar system, quote unquote, moving through the galaxy as well? Right? If we're going 1,000,000 miles per hour, isn't that an additional vector that would affect the propagation rate? Like so they didn't even know about that at the time. Wouldn't that create an additional fringe shift?
Yes, it would. Well, it would depend on the model they're using. Remember, I pointed out that they measured the angle, not what they measured directly, but said, okay, we're on the Earth. The Earth is rotating around the sun, so they assume that. And then they said, what we really need is to know how the sun is moving through the Milky Way galaxy. So the directions that I gave in that chart are the directions in the so-called galactic coordinate system. All right, with the Milky Way. The Milky Way is the center. All right. You know, we talk about heliocentric, but of course, nobody in mainstream believes in the heliocentric system. It's inconsistent with relativity. Relativity says it doesn't matter, you know, where I measure
At least,
the motion.
dude, see, this is so such
the
good
results
stuff.
will always be equal and opposite. Well,
Except for that fucking sound, right?
Right. So what would be your take of the audience where you have the Michelson-Morley not showing the fringe shift predicted? Of course, they say it's a null result as if there was nothing, but there was in fact something consistently measured, like you just covered. Then you have Michelson-Gale-Pearson, and it's showing its correspondence to the latitude. What's your take on how could you possibly kind of combine these with any type of heliocentric explanation, right? Because if you combine Michelson-Gale-Pearson and Michelson-Morley, both assuming the framework of the ether to actually get the measurement, would you agree that actually definitively refutes heliocentrism and it shows the only viable option is that the Earth is stationary and there's a sidereal rotation around it?
Yes, but I would say that there's many experiments like the Aries failure.
Right? They all keep finding that, he says.
Destroy right from the beginning. And they've
never
ignored
not
it
find
for
it.
250 years.
they never not find that, it turns out.
They only never not find it when the medium is the square root of the vacuum or whatever times 2.
Yeah,
relabeling and ignoring is their main tactic. Like I saw that when I was looking into Miller and like his work. Because he would just people would critique his work and then he would just bang out a bunch of experiments and like and do all the control variables that they were critiquing him on, and then he would just debate people live on stage and he would just crush. And so what they started doing is they just started ignoring him because no man could refute him. You know, he would show up with his measurements and data sheets and all that, and he's like, let's rock. And you know, they literally just had to start ignoring him towards the end of his career because that was all that they could do with him, is just not address it.
Yeah, once they choose a path, okay, then they have to be committed because they can't. If pride won't allow them to say, I was wrong, let me reconsider, you know. And that's one of the things you have to fight, the inherent pride and the resistance to change. I mean, the books have been written about paradigm shifts and how difficult they are. And that was what I tried to point out with the mainstream versus dissident, the river flow.
Oh, it was a great analogy.
Yeah, it's the resistance. You know, the water has inertia, right? So once it starts.
All right. Let's see here.
Yeah, it looks like he spends a lot of time on these slides.
Oh, dude. So like the slides are like, you know, he's got a couple graphics up and then he just rips like 5 to like 10 minutes like off the dome. It's awesome. Like per slide. It's great.
Nice.
Yeah, but yeah, we covered we tried the back cover a lot of what wasn't chimed in on because of technical difficulties there. So we were playing a little catch up because I wanted to let him know, like, you know, my bad, I didn't mean to leave you in the dark, dog, for 2 hours straight. So, and then he gets back to it here and explains the Foucault situation.
Yeah,
so,
he seemed really happy to have you guys to bounce things off of. Like he leaned back, put his arms over his head.
He was like,
big
oh,
sigh.
thank God,
like,
the boys are here.
All right, now we can have a conversation.
Yeah. I feel so bad. Because like, yeah, I could have, but then it would be like a 10 episode series, you know, because he would get like one slide done and we would just analyze it to death. So, do you want to hear? Do you want to hear Foucault?
Oh, no.
Okay. Do you want to hear?
Can I hear food? I'm new to all this shit, man.
Yeah.
This is really interesting to me. Thank you.
All right, no worries, bro. We're Foucaulting it up.
In the history so far.
Not right now.
Yeah.
That time when you finish and hide back in the.
All right.
Okay, so they see the rotation mainstream sees the rotation of the pendulum plane, and they say, aha, this shows that the Earth is rotating. Because if I were on the Earth and it
We'll get through
rotated,
it
then
quick.
if the plane of the pendulum kept aligned with the stars, in other words, whenever you started it rotating, it was
He's not
pointing at
even
a certain
moving his mic.
stars if you projected it there.
Dude,
Why is it squashing so much?
it's rubbing against his neck, dog. Don't worry, I step in like, I don't know, a couple of minutes here, and let me just skip ahead so it doesn't, so we don't have to hear that again.
Basically, it says that.
Okay.
Dude, so as you notice now, the headset's now on the other side of his head. So issue fully resolved.
Inertia that we observe on Earth, that is the resistance of objects to being moved, is basically due to an interaction with the stars. How that occurs is not explained. It's just a principle. And like I said, we'll cover it later. Now, how did the ether people, which is me, explain the Foucault pendulum using ether? All right, we have the Earth fixed, and we have a band of ether, which we've already seen from measurements, surrounds the Earth, 0 at the pole, maximum at the equator. And if we set the plane of the pendulum moving north-south when we first started, that's important, because that means that the northern swing of the pendulum will be at a slightly less speed of ether, okay, than it is in a southern position. So when the swing occurs, there's a slightly greater push on the northern part of the pendulum than the southern. Of course, this is in the northern hemisphere, right? Which is what the diagram shows. And this occurs anywhere that you're on the surface of the Earth. The latitude above always has less speed of ether than a latitude below. The incredible thing is that the swing is only a few feet back and forth. And yet that difference is big enough over 24 hours to make the whole thing rotate. That is really remarkable, but that's the explanation, and it's perfectly logical, given that there's an ether wind that has been detected. And so Michelson-Gale were wrong. You can explain what they measured, not as the rotation of the Earth, but as the rotation of the ether around a stationary Earth.
GG. So it's following. What's up?
He's trying to explain it with a spherical model of ether movement. Remember that, like, Bob's wind that flattens out the globe and it has the quickest speeds in the south, which would be like, that's.
It's
I
funny
feel
because
like
he stays in the one side of the equator.
Yeah, exactly. So I feel like his explanation is a little off.
Yeah, so you know how it was like it's just following the motion of that toroidal field or whatever, so to speak. Like as it's decaying, you know, the motion's decaying.
Centripetal inward. What the hell is it?
Yeah.
Fucking what the hell did he say?
Yeah, centripetal Hoosier bubble, or whatever. Right.
The centripetal convergence, the centrifugal divergence.
Yeah, that. So like, but he's only
yeah, that.
Yeah, that. Yeah.
Oh, it was actually that. Okay, I thought it was.
He's only trying to explain it with like the first half, right? So he's trying to say from the equator to the north. So that would be the northern hemisphere. But the fastest speeds are not at the equator; they're in the south, right?
We don't have any readings for the south.
Well, we do for the Bob wind. That's all readings, right?
I'm sorry, for ether wind.
Yeah, well, for like wind, for anything. for like everything is faster in the south.
Well, not for ether wind.
No, but like so when the globe spins, that's the only time that you have zero force exerted at the equator, right? None of that's. How do we replicate that for flat Earth? Like the equator has the middle of the ether vortex.
No. Well, none of that's like been substantiated. Like they don't have pendulum experiments that we can even verify that. But I'm just taking the example of like the pendulum does persist in that thing though, right? Like even it doesn't matter or not at the equator, right? It does that. Like that's just kind of what my thoughts on it are. Is it's just following the that natural movement of the ether as it decays, right?
Yeah.
But if you keep it in perpetual motion, right, like with a slight adjustment, that's where you're gonna get it to map out the entire thing, with that circular pattern in there up at the top.
Yeah, I don't know enough about Foucault's pendulum to say any more. Probably.
Yeah, well, what's cool though is we'll head over to Geo's later and ask him or show him this because he's the Foucault daddy. So, so we'll see what's up with that. But yeah, I sent him my thoughts on that with the decay following the ether path, kind of, and he agreed. So GG.
Nice.
Okay, the Bible also supports the stationary Earth, as you probably know. There are 30 verses in at least 30 verses in the Bible that say either the Earth is
All right. Let's see
at
here.
rest. What does it say? The foundation is moving.
We don't need to listen to him.
Okay.
How long
Trying
did you want to
explain
make
how
this
the
Aether
Bible
Round Table?
explains a globe?
Yeah, yo, how long you trying to round table, Toby? Because like I'm down to round table as long as you know you guys are down to table the rounds or whatever. So what's up?
I mean, I'm still live. I'm in no rush to close it out, but I mean, if anyone
All right.
needs to be done, we can be done at some point.
Well, no, you're gonna clip all the good stuff, right? That's probably easy because I feel like people don't watch stuff that's more than 2 hours. But Alan has a very opposing view on that.
Oh, I don't give a shit, dog. I'm going until
They'll
it's
fucking put up
done.
6
And
hours. Yeah.
yeah, they can figure it out or not. Like I don't. It's fine.
Well, since we're like still on topic and going with the flow of like this particular discussion, I'll keep it live.
Yeah.
Once it starts to like kind of just go into more free flow, everyone talking, I'll probably end it around that time.
Well, yeah, but if you do your thing and get all the good clips, then I'll just steal those and put those up, and problem solved. So I'm not worried.
Cool. All right. So here he goes over this really cool kinematics and dynamic situation. So if you remember back from the debate the other day with T-Jump and Witsit, where he was going over the kinematic equivalence and all that with dynamics and stuff.
And it went right over T-Jump's head because he didn't understand any of the words. Yeah, I remember.
Yeah. So here we're gonna see what it looks like when somebody understands what all the words these means.
Now we come to Einstein. Okay, Einstein claims that he knew nothing about the MMX experiment, even though all of the physics was in an uproar, in a crisis mode, because since 1886, the MMX experiment, they seem to have found, they claimed they had found no ether, and so they had no explanation of how light moves at sea if there's no medium for it to move in, because ether was the medium in which light is luminiferous, that is, light-bearing. All right, so I have a paper that goes into detail about the 1905 special relativity paper. All right, he claimed that he didn't have knowledge of MMX. He just dreamed this up on his own. Let's first consider what is right about the paper. Well, he divided it up into two divisions. The first section is kinematics, and the second is dynamics. This will turn out to be, in my interpretation, a very important distinction. You must know the difference between two branches of physics, kinematics and dynamics, in order to understand the model that I will present. Okay, this is what he did right. Kinematics and dynamics have to be distinguished, and he has two sections.
About to get wild,
but then guess what? He didn't apply the concepts correctly in the two sections, so it was worthless. He distinguished that he's going to treat kinematics and dynamics differently, but he didn't. One of the claims in the paper is that there is something called proper time. That is.
Yeah. So as we move forward, the distinction being one's just describing motion, one's describing why it's happening, and it's making predictions, and that's the dynamic one. So for the kinematics, they can just do whatever and analyze the motion that's
mathematically regurgitate. They can do anything there, dude. Right?
Right. And so Einstein's paper, he says it was divided up between kinematics and dynamics. So as if he's going to treat them differently, as if there's going to be a distinction between abstract mathematics used to analyze motion, relative motion in a system, and actually applying real forces to make a predictive model to actually explain motion based on what you're saying is the abstract mathematics, right? So saying that the gravitational influence of X, Y, Z is the cause of the mass attracting mass, right? So like Jupiter's mass is attracting this planet, that sort of stuff, right? So as he was mentioning previously with that equation with gravity and Kepler's laws, and how when you reduce it down, the mass cancels out because it's irrelevant, it's made up, and it's purely a kinematic equation. It doesn't matter at all what the mass is. It's all scaled proportionally off of a constant. So it just scales invariantly, and they're all just like amazed with themselves that they're able to make predictions based off of that, and they think that it's physically meaningful because they don't realize that, I guess, that you can just cancel out the mass when you reduce it down to what it is. So it's just
dude.
Go ahead.
Michael Brenner pointed this out on Quora all the time, and Dave has been fucking rubbing this
Dude.
in our faces and getting all the
Oh,
quotes in the meme. Kinematic and dynamics, guys. Kinematics and dynamics.
Dude,
They
shout
can
out.
mathematically like scrub anything kinematically, and that's all relativity is. It's a mathematical fucking regurgitation circle jerk of kinematic equivalent nonsense. And then he's like, "Oh yeah, well, there's dynamics, but we don't. We'll do the same mathematical nonsense for that." And poof, like what?
Dude, shout out to Dave, man, who's always been on the Michael Brenner grind, dude. And Dave, get those quotes ready, dog, because we're closing on them for sure. And then yeah, so there's a surprise for Dave at the end where we're gonna look at the language of the ancients, and your boy Bennett is on board with that, dude. So we'll see what he has to say about it. Dave, so keep an eye out for that here at the end. But yeah, so that's the distinction between kinematics and dynamics and their relationship and their usefulness. So one, you're analyzing a system, you're like, oh, okay, you're starting to make predictions off of it. You're like, okay, it could be this, it could be that. You're starting some hypotheses, right, to apply to your abstract mathematics for a cause and effect relationship. And then you start doing experiments, and so you apply dynamics to it, where you're going to see if the experiment holds true based on your kinematic predictions, and that's like a pass or fail if what you're putting forward in your kinematic framework holds true in reality, right? So that's the distinction here. So Einstein's like, yeah, boys, I got you on that kinematic and dynamics. No worries. Well, I'll separate them. Turns out he didn't. And this is what is going to be covered here. This is hugely important to where we're at today, and why people think that when they're calculating with these equations that there's meaning behind them, and they're so attached to the effect, because this is advanced, math. When they get into the differential calculus and all that for the tensor calculus and all that, like that's high level stuff. So you're gonna have a huge attachment to that because you've been through an entire pipeline of training to like learn that knowledge and absorb it. And like, are you really gonna part with like, oh, it's actually physically meaningless and it's just for funsies? It's
Dude, there's no way that your ego identity is wrapped up in not understanding something that you're gonna understand it.
No way, bro. No way. So this is.
Hey, Alan, would this be the case where, basically Einstein steals the Lorentz contraction or the Lorentz transformations, which are based on the observations of the fringe shift, right? So the observations of the fringe shift to explain the fringe shift, which was optical, right?
Yep.
And
then yes.
And then Einstein uses it in his theory of relativity as if it's some sort of explanation for a physical or a dynamic explanation for the observations.
Dude is well informed.
It's funny you mentioned that, Napalm, because you're 100% dead on. And as this video plays on, you're going to hear exactly what you just said as if you said it.
Oh.
So that's what's up, bro. That's what's up. So here we go.
I pay attention every now and again.
Hell yeah, bro. Here we
Only
go.
the good stuff, though, it seems.
All right.
Time is measured differently when you're at rest as opposed to when you were moving. And this is the formula that comes from the Lorentz formula applied to special relativity. Now, what does ether say about this proper time? Well, the v that's measured here is the speed of the object. But the speed we need when an object is dragging ether along with it is also v. In other words, when an object moves through ether, it drags ether along with it at the same speed. So that means that the value of c must be changed to c plus the speed of ether, the ether that's being dragged by the moving object. So that means that this formula is incorrect. It has to be corrected for the effect of ether. And of course, he's denying that ether exists. As far as length contraction is concerned, that's not observed. If you read the paper, he starts by saying, we measure lengths with a rigid rod. Okay, this is a device he uses to measure how long an object is. He uses these rigid rods, and they're always the same length. Rigid means they cannot change shape. And what does he find? He finds that with a moving object, the length contracts. Well, that means his rigid rods would also contract. And that was the basis for which he used to derive the equations of special relativity. So we have a...
So, all the times that we're like, hey, you couldn't even verify it in this frame, it's an unfalsifiable claim. and they're like, nah, there's definitely, you can do it for sure.
Yeah,
Definitely,
someone's done it.
dude. Yeah, dude, someone for sure out there is contracted. Never once, guys. And the logic behind it, as we just observed, the rigid rod would also have contracted in the frame as well.
So the apparatus
Conflict of-
used to make the measurement also suffered the same condition that miraculously forced my measurement to not match the heliocentric prediction. But because it would itself contract, I'll never know, and it's untestable. And just trust
It's
me, bro.
baked into the name. Relativity.
But just
Relative.
trust
It's
us.
just all relative.
Dude, and not only that, it's general relativity because it's all based off of approximation. So it's kind of like a double entendre joke on you, because where it's like, it's all relative, bro. Really, or it's general. It's a generally correct theory, right? You know, it's just
Dude,
an
the only like self-respecting pseudo-intellectual position one could take and not be a flat earther is this well-informed geocentrist with an ether wind. Like,
Dude,
if you understand all of this, you can definitely remain not a flat earther, and we'll respect all of you anyway. Like, you know all the truths except for the shape one. It's fine.
It's all good. You get a pass. You get an F pass or an FE pass, right? All right.
Like, dude, because we always make fun of relativity, but it's the cornerstone, right? And we always attack it. But so this guy, the only way you can retain your heliocentric belief in mythology is to be an ether wind enthusiast geocentrist like this fella. Otherwise, you have no fucking position and you believe in pseudoscientific nonsense. You know how like Ruhip is like, I don't need relativity. It's like, well, actually, no, you and everybody else do. You need it very, very much.
Very much.
God bless Ruhif. Yeah, man. I mean, well said, really, because it's the glue that holds it all together. That's why it can't be scrutinized. It's above reproach. And we're gonna find out here that I'm just gonna let this play out because it's pure gravy. Like, we've already amped it up enough and analyzed it.
Immediately.
It still requires
what
gas
his
pressure
results
without
say
containment.
and
How dare you?
what his assumption
Boats and
said.
curves.
He said he was using rods that don't change shape, and yet he's claiming that lengths contract. Again, this has never been observed. Whenever they claim it's been observed, it always turns out to be a faulty measure of time, which is interpreted as a change in length. Now, in the beginning of this paper, he talks about Faraday's law and it being reversed. I'm going to talk about Faraday's law in part 2, but just you should note that what he's talking about in the first paragraph can be explained by using an absolute reference frame, which is the laboratory, not the relative motion between the charged disk and the magnet and the electric charge, which is Faraday's law. Okay, don't worry about this. I'm going to cover it part 2. What did he say about the MMX? In the heliocentric system, the Earth is in solar orbit. Okay, well, we know that's not correct. And that, again, I could go back to Airy's failure and say that Einstein should have known that. Of course, mainstream all believed in the heliocentric model. So that's one error in his assumptions, that the Earth is in solar orbit. And the other is, of course, that there is no ether. So those are the two key faulty assumptions in the special relativity paper. And they have been proven to be incorrect. Let's look at his postulates. There are 2 of them. The first one says the laws of dynamics are valid in inertial frames of reference. The problem with that is, what do you mean by an inertial frame of reference? If you speak to some mainstream people, they say the Earth is an inertial frame, okay, because we're at rest. And they're contradicting, of course, their own model, which says that the Earth is spinning and orbiting the sun. Other people will say, no, you can't use special relativity because you're not in an inertial frame of reference on Earth. The Earth is rotating around the sun, and it is subject to a centripetal acceleration and centripetal forces. So it's like strike 1 and strike 2. Inertial frames of reference are undefined. In part of the paper, he says motion in a straight line at constant speed is an inertial frame of reference. But that is a kinematic definition. That is, if I measure something and it's moving that way, it's an inertial frame. How do I know before I measure whether I have an inertial frame? I can answer that with my model, but special relativity can't. The postulate 2 we've already seen.
But no, it's all relative and all this. Like, no. Like, is it though?
Dude, it's moving because I know it's moving, and I know it's moving because it's moving.
In that the speed of light is c plus the speed of ether. If there is no ether moving, yes, the speed of light is c. But in vacuum or in any other place, the speed of light depends on the speed of ether. We will be disproving it with the Sagnac effect, Ruyen Wang's experiment,
Nice.
which was only 18 years ago. The name of the model that I
2004.
use to explain all this is alpha, absolute lab frame plus fluid ether. So if people ask
Nice.
me, what is your model? Then this is basically what
Oh,
it is.
it's the alpha model, bro.
Fluid ether.
Yeah.
Oh, we're gonna adopt that.
Another problem with
Dude, I
Einstein
mean-
is
Sure.
he apparently thought that he knew so much that he didn't need any references. Pick up a physics paper today.
Dude, this is
You'll
hilarious.
see a long list of references because you have to say what you're building on. You have to say, what experiments am I relying on? What theory am I using? What support do I have for the things that I say? Well, Einstein has no references. He has nothing about Michelson-Morley, has nothing about ether explicitly, no ether experiments, despite all of the ones that I mentioned occurred before 1905. And there's a lot of other things, but they're more like details. Okay, any comments on that?
You know, your boy shut up immediately, dog. It's like, sure do,
Yep,
buddy.
sure do.
Waiting for you to fucking stop so I can fucking jump
Flash
in.
bang and clear.
Yep.
Okay.
So yeah, to touch on the historicity of Einstein and his miraculous conception of
Woohoo,
time and space
historicity.
contracting and all that. Yeah, so he tells that story that he just kind of came up with it on his own, and there's actually like different stories that he, because when you're lying, you forget, you start telling different details. So he tells like several different stories about its conception, but still maintaining that it came up with it on his own, even though the entire theory adheres to Lorentz symmetry with the first postulate, right? So like clearly adopted his entire framework. But there's like documentation that came out with his private letters between him and his wife, where prior to 1905, he was writing to his wife saying, "Hey, I heard about Lorentz's new ether theory and all this stuff, and like I got to look into this. It sounds awesome." And there was another guy, Drew, who wrote a textbook on optics, and he did like an in-depth breakdown of the Michelson-Morley experiment, explaining it all, and like just went into great detail on it. And that was in the book that Einstein was like, "Yeah, I'm definitely going to read these two specific things and get down to business on these." And then and there was another one too, I forget off the top of my head.
Well, look, there's also, of course, this infamous quote here where, he gives a speech at Kyoto University and he says, "While I was thinking of this problem in my student years, I came to know the strange result of Michelson's experiment. Soon I came to the conclusion that our idea about the motion of the Earth with respect to the ether is incorrect if we admit Michelson's null result as a fact. This was the first path which led me to the special theory of relativity."
You don't say.
I mean, and then since then I've come to believe that the motion of the Earth cannot be detected by any optical experiment, though the Earth is revolving around the sun. You also have him here saying,
I like how he completes that now.
he says, "But
just
when
to
I was a
spite the
student, I saw that experiments of this kind had already been made, in particular by your compatriot Michelson. He proved that that one does not notice anything on Earth that it moves, but that everything takes place on Earth as if the Earth is in a state of rest." So he point blank says that's actually his motivation to come up with special relativity in the first place. 2 different times says he heard about it in his student years. The fact he flip-flopped right before he died is just highly suspect.
Yeah, we call that CYA. Cover your ass. He had several things that he got wrong. In general relativity, they discovered in the Hubble
Dude lives in
law
the city, huh?
that apparently the universe was expanding. The Big Bang was true, but he had built a model in general relativity that everything was static, that the stars were fixed distance from the Earth. So he had to add a cosmological constant to his equations to allow the expansion. Then he flip-flopped, as you know, with the ether. He said there was no ether in special relativity. And then, 1920? 15 years later, when he's talking at a conference in Europe, he says, of course, there's an ether. It's nonsense to think of general relativity as of a curving space.
I remember that quote.
If space is nothing, right? If space is nothing tangible. So
Exactly.
there must be. I mean, he has a trail of contradictions, and the way the mainstream plays it, you can quote him to prove whatever you want because he's on both sides at different times. He's on both sides of a question.
Yeah, exactly. And then like here he is in a letter to Hendrik Lorentz in 1919. It would have been more correct if I had limited myself in my earlier publications to emphasizing only the non-existence of an ether velocity instead of arguing the total non-existence of the ether, where there has to be physical qualities. He also says here, this in 1938 in Albert Einstein Evolution of Physics, page 159, this word ether has changed its meaning many times in the development of science. At the moment, it no longer stands for a medium built up of particles. Its story, by no means finished, is continued by the relativity theory. And he has another quote where he says, space without ether is unthinkable.
Yeah, that's the one. Yeah. That's the one.
Yeah, crazy, man. It's just so crazy because what do you think about this? And this is a bit more nuanced, but Newton said that basically gravity was an intrinsic property of matter, and he couldn't explain how it would be instantaneous without a medium, and then there's no time variable in gravity, blah, blah, blah. Fast forward to Einstein, he basically says it's an emergent property, like it's an effect. Gravity is the effect of the bending and warping of space-time. Well, if you have a background ether, and it's waving or longitudinal vibrations, right, so not transverse, but it's vibrating, well, in a way, you have warping or displacement, right? And then that pressure would result in an emergent property called gravity. So Einstein basically hijacked the ether is what I'm saying. He needs the ether, and all I did was just rephrase it and remove what the ether actually is to try to keep the Earth moving around the sun. Do you agree?
Yeah, basically. It's a what is it, 3-card Monte? Try and guess where the truth is.
Dude, it's been a wild ride.
Is it over here? Is it over here? Is it over there? Is it over here? Yeah.
That's exactly what it is. Try and find the truth in this barrel of snakes.
And they won't tell you. They won't tell you any of this.
No, not a lick of it.
Now, remember that all of the experiments I went through are important because it's the scientific method, right? We're using what we observe, the models that we use to explain it, and the logic
I'd like to see
examine
QE
whether
do
there
a
are
breakdown on
contradictions
that
or
section.
anything that's contrary to what we're proposing. And so far, I haven't seen anything
I
that
would
will disprove
Yeah, no,
the,
I meant like he should do it so
the,
others should watch it because I'll
geocentric,
never.
the geocentric model or the fluid ether, okay? The absolute lab friend.
Right. I want to say one more thing. When you were bringing up, what they try to say is that the stuff would have to move faster than the speed of light, right? Well, this is actually Einstein in the Special and General Theory of Relativity, 1920, page 89. He says, in the second place, our results show that according to the General Theory of Relativity, the law of the constancy of the velocity of light in a vacuum, which constitutes one of the two fundamental assumptions in the Special Theory of Relativity, and to which we have already frequently referred, cannot claim any unlimited validity. Yeah, he straight up says it can go faster than the speed of light in his own work.
Yeah, general relativity says that light speed can change. Special relativity says it can't. But if general relativity is the extension of special relativity to include gravity and high speeds, okay, that's what they claim. Then what happens when you have lower speeds, okay, and lower gravity? The two should match. But they can't because one has
Absolutely
an
not.
ether model. The
Not
other doesn't.
inversely
One says the speed of
proportional.
light is
Yeah.
constant. The other says it isn't. And yet they must match because
Everything that
eventually
all my
general
theories are
relativity
based
must
on
smoothly match
cannot claim
special
any
relativity
unlimited
as you reduce the speed of an
validity.
object and the force of gravity.
What?
Yeah, that's a great point. That's a great. But they would have to at some point overlap. His excuse for that was that obviously things apply in different situations. But just like you said, if you get to a low enough energy state, it should overlap.
Yep.
Yeah, absolutely. And then before we move on real quick, I wanted to touch on what you were saying about kinematics and dynamics and how in Einstein's paper he's like, yeah, we're going to distinguish, break it up into these two sections, and then he never does. So what you pointed out in your paper is the English translation for reference frame and coordinate system, and how one implies an observer, like a dynamic system and like actual things, and then the other one is like a fictitious system that you could use for analytic purposes. And I thought that was really crazy that they have a specific word for it in German, for what's to distinguish the two, and they just uniformly made the translation to apply to the fictitious one, right?
Mm-hmm.
Yeah.
Yeah, if you look at special relativity, the German words and the English words are almost exactly the same.
How did you know that?
Where the
I read his paper on it. He linked it to me.
Oh, you read his whole paper?
Oh, dude, yeah, dude. I had no idea what kinematics and dynamics and stuff was like 2 weeks ago.
No shit.
Yeah, I had to jump in quick, dog. I knew homie was gonna come through with the hitter.
Respect,
So
dude. I was like, hey, how did you know that, Alan? Oh, you read the whole paper. Okay.
Oh, dude, like you want to see
that explains
Yeah.
that explains a lot. Yeah, okay.
Yeah, with highlights, dude.
Yeah, see, because
this is where I go over it. This is where the magic happens right here.
a K. Coordinate Staten is the German word, and reference frame, where the C becomes a Z. That's the German word for reference frame. So you can't miss them if you read even in the original German. And what you'll find is he only uses
so
reference
he
frame
said
once,
that.
and
He made
doesn't
that
define what it means.
observation and he published it, and you just recited it because it was awesome.
Yeah, yo, hold on 1 second.
I misunderstood what happened there.
Yo, Eric, before you dip, are you he used to work with Ron Hatch, he said. He in the same office.
Oh, really?
Yeah. So this guy, Toby, you know how you bought the book and uploaded it or whatever? This guy Eric here, he uploaded it to Library Genesis. He's the one that uploaded it. And he said that he said that he worked with Ron.
Nice.
Hello, can you hear me?
Yes, sir.
Yeah. Hey.
Oh yeah, I'm Eric E. Yes, I worked with Ron Hatch and or in the same company, and I'm also the one that uploaded the book. I saw it on Discord.
Oh yeah.
Nice.
Uploaded, and then so I said, "Oh, that has to go up to LibGen." So I uploaded it to LibGen.
Thank you.
Much
Thank you for all your work.
man. Yeah, dude. Yeah.
I found it very odd how hard it was to obtain the book.
It was published quite a while ago, and I got my copy from Ron himself. So,
Gotcha.
Dang, you got that all exclusive, dude. That's what's up.
Damn.
right.
That's awesome.
How much? Do you mind if how much did you have to pay for the book?
I think it was like around 150 with shipping.
Wow.
Yep. Yeah, that sounds about right. Yes. Yep. Well, hold on to it. It certainly is a collector's item now.
Oh yeah, he passed recently, didn't he? I'm sorry to hear that.
A number of years ago, unfortunately. He was a nice guy. He used to go online and talk in like forums or write in forums, but he stopped doing that because of too many well, let's just say bad comments that he received.
Yeah, dude.
So-
They had to hire an entire division of people to troll online because to shut stuff like that down, because good people were just out there like, hey, did you guys know that everything you thought like isn't represented correctly in physics, and here's why, and then they had to hire people to get rid of that. So that's unfortunate.
So is Eric E new to Discord or just new to me?
New to Discord, I think.
Oh, nice. Well, welcome.
Well, thank you. I don't know if you know him, but I mainly am in Blue Marble Sciences Discord channel. He's the one that created a replica of the Cavendish experiment in his garage. And it was very sensitive. In fact, it picked up the earthquake. It acted like a seismograph and picked up the earthquake in Haiti one time. I was in a live. I saw that as it happened because he was live streaming it. But anyway, that's where I'm mostly. But I'm new to Alan. I really want to thank Alan for getting Dr. Bennett to give this presentation. I'm looking forward to the next one.
Yeah, thanks, man. It was dope that it all worked out. I've been working on this for like a month, trying to get the timing right and everything, and it all aligned perfectly today. Even with the internet disconnect, it all worked out perfectly. So I'm glad that it was able to happen, man.
Yeah,
There's going to be at least
amazing.
I hope there's more than just one more. Maybe it sounds like with the amount of material, there's going to have to be at least two more.
Well, listen, gauging how this guy is lighting up when people show interest in his work and have an intellectual level to be able to converse on the things that obviously he's so interested in, we're going to be seeing a lot more of Bennett. I can probably guess.
Yeah. Dude, yes, I hope so, man. He's such a cool dude.
Well, I'll let you guys continue on. I'm glad to have been able to say hello to you all, and Alan, thank you for inviting me, and I'll just go on mute right now.
Thanks for being here.
Yeah, welcome, Eric, man. We always appreciate new people who aren't, awful.
Okay, have a good evening, everyone.
Yeah, you too, man. Peace.
Like if Blue Marble Science came around, it probably wouldn't be so welcoming, but
He uses coordinate system all over the place, which means mathematics, right? Not physics. And he uses reference frame when he needed to avoid a contradiction.
Dude, exactly, dude. That's what's so crazy. It's like so ambiguous, and then like the mainstream levels of academia have like such freedom of interpretation to just kind of say like, well, sometimes it's this or that. So like one of the things that I noticed is that some people that I'm talking to about like covariance, for example. So how you were saying that the two systems, special and general relativity, have to be mathematically equivalent through covariance. Like a lot of people that I've talked to, they have no idea like how to even verify the first postulate, and that that they have to be equivalent in that regard. And like I think that's kind of how they're getting away with it, because like the theory has gone. It's so bad now. Like it's so obvious that it's just gobbledygook that like they can't even teach you the rule book to it anymore, because once you start realizing like what you just said, it's like, oh, it's not valid, it's over, right? Because it's literally just math. And yeah, that's it. That's what I wanted to contribute to that.
Oh, what a tangled web we weave when first we practice to deceive.
Okay.
Famous quote.
Yeah.
I want to correct one small statement that I made. I've been talking all along about geocentrism. Okay, how would you experimentally prove geocentrism, which means the Earth is at the center of the universe? Well, you would have to know what the boundaries of the universe are in order to know that the Earth is equally distant in every direction from that boundary. Do we know the boundary of the universe? No. We know the boundary of the presently observable universe, or at least we think we do.
Just simple logic deduction,
right? Just
like hold the phone, guy.
Yeah.
Hold the phone. You're trying to tell me you know the dimensions of this bitch, and then within that shit, you know the expansion rate within it to facilitate why it's symmetrical from our perspective, but it's not. But it's also symmetrical from any perspective. Like what?
You've ascertained the edge of the universe from your perch right there on wherever you are. That's interesting. That's great.
Yeah.
Cool.
Well, you observed the system from outside of it, well, within it. Well, that's cool, man. That's cool. I didn't know you could do it like that. Like, dude, like imagine they told us that this was an option to say in school when they were telling us all this stuff. Because like when you're absorbing it, like you don't really like you're like, oh yeah, dude, expansion. And then Hubble looked through the telescope and he was like, well, shit, dude, it's got to be expanding like a loaf of bread. Like, all right. Guess we're rolling with it, and they just never stopped rolling.
It's easy for like a kid to realize how crazy some of this stuff is.
Yeah, but then it's all that appeal to authority, like all these informative, authoritative figures and teachers and parents are telling you that this is real. So you suspend your own disbelief and you go, I must be crazy. The adults must all be right.
For sure, they probably They smack you over the head with it every single
Yeah,
day.
it's maniacal because you just like succumb. We all succumbed to it. We went, oh, I must just not get it. Right? Everyone else clearly already figured this stuff out. That's how they get you.
That attitude is what made me how I accepted like the surface level narrative of it when I believed in all
exactly that.
Because I was like, this is way too complex. I'd watch a presentation on it or something by like Johnny YouTube or something, and like learn nothing really of value to like that I could repeat to someone to go, oh, you know how space and time contract? Like what? Like it doesn't mean anything. You know what I mean? Like you can't add like there's nothing there, but you don't. But it sounds. But you sound like you're saying something profound, you know? You're like
just like you used to watch like those science dramas like about the expansion rate of the universe and black holes and quasars and supernovas, and watch it and feel informed, and I'd regurgitate later to uneducated people about how much I knew about the space expansion and feel like I was educated. Oh, it was terrible.
Bro, did you know that a gamma ray bursts from a black hole that is birthed out of Einstein's field equations of the compression of
the mathematical boogeyman of the sky, which they created from this mathematical obfuscation of the derivation of the measurements of the sky.
Yep. So like, yeah, like if that shoots out an energy beam, like we're done. It'll melt the atmosphere that may or may not exist next to a vacuum. It's like, oh dude, that would suck. Yeah, man. So just excellent
and there's infinite universes.
Yeah, just a solid argument right out of the gate. Just on that, like, okay.
Simple logical deduction. Yeah, what you say, sir, is nonsense. Moving on.
Yes.
Have you guys ever seen Turbo Encabulator?
Who?
The Turbo
No.
Encabulator. I just put the link in the side chat. It's a perfect example of what you're talking about.
Oh, gotcha. Is this technical jargon to okay, or something like that? Gotcha.
Exactly what they do on purpose.
The turbo ejaculator. Oh yeah.
The redshift as a distance marker. So to say that the Earth is geocentric, center of the universe, first of all, is not really provable. What you can prove is that the Earth is on the axis of rotation of the universe. Okay, because we see the stars and everything else rotate cylindrically around the polar axis. Only the objects that are on the Earth's equator actually have the Earth as the center.
I wonder how he feels about the southern stars.
And what does Scripture say? Does Scripture ever say the Earth is at the center?
Dude, that's why we need to put together like I'm gonna ask him if he's down to like hear some stuff. You're gonna do like a full presentation, like me, you, and
we show you some stuff and you just listen for a little while. What do you think?
Yeah, dude, I'm gonna see how that goes. See what's up.
Nice.
No, always says the Earth is at rest. Okay, the Earth does not move. So technically, the theory should be called geostatism, meaning the Earth at rest. But if I use that term, everyone goes, "What the heck is that?"
Geostaticism?
All right. So I use geocentric.
Yeah, dude, new terminology.
I like that.
Yeah.
Yeah, I'm gonna be ripping that one too.
Yeah, geostaticism AF. Brother.
That's right up there with the geokinematics that we're gonna be rubbing in people's faces.
Mm-hmm. And also the pressure getting mediated.
Because everybody uses that and thinks they know what it means, but actually you couldn't test whether the Earth is at the center because you don't know what the boundaries of the universe are.
Right. Although we can say that based on what we can observe, right? Like based on what we currently have access to observing, it presents itself as if the Earth is in the center with an even distribution all around. It's not even more so in equal distance, right? Equidistant observations. So like based on what we currently know now, like that's why I found so interesting about this whole thing is when I found out, oh, they saw the distant galaxies move in relation to the Earth, and they're like, uh-oh, looks like we're in the center. Oh, accelerative expansion, redshift is a distant marker, blah, blah, blah. But Hubble straight up says, if we're incorrect about our interpretation of redshift, then it would actually mean that the universe is closed, finite, much more dense, everything is much more local, and suspiciously young. So Hubble himself says that if their assumption about redshifts wrong, it looks like the universe would be a closed, finite system with the Earth in the center and stationary, and then everything is more densely compacted and it's much younger. So that gets omitted. It gets completely omitted that he knew when he proposed it that it could be wrong, right? Then he says the idea of us being in the center can never be disproven, but we must avoid it at all costs because of the horror of a special and unique position is intolerable, right? Like, is this science or is it like
philosophical perspective?
It's a game that the scientists play. That's what it is, a mental game.
It's a shit test.
Science
How much will you believe before you push back
philosophy?
and say, I'm done, like I'm cashing out? That's what it is, just straight up.
BS contest.
Yep.
Okay, I agree with the last part of what you said, Austin, in quoting Hubble, that if the redshift is not the Doppler shift, meaning not caused by the velocity of recession.
I see you already incorporated that screenshot, Shane.
Stars that we're observing,
Respect.
but it has some other reason. Then all of this Big Bang stuff, all of that collapses. Okay, so like he said, we can't allow that because it will prove that all of us are wrong, and can't have that.
Yeah, it's crazy. Why are you so scared of being special, bro? Don't make it weird.
Yeah, you've discovered something that's important, and yet you're afraid to.
So he's a straight
point it out.
creationist, then I guess.
And Hubble,
Yeah,
by the way,
he's-
never
yeah, he's
really
a-
No
accepted his own
qualms.
Hubble
All
shift.
right,
It was
cool.
called Hubble shift after.
That's
I think
good.
maybe after he died, but maybe after he did active
So do
research.
people accept
But I
their
know that
divinity? That's nice.
the name that is
Yeah.
attributed to him is not something that he totally agreed with. He always looked for another explanation of the redshift other than recession.
Yeah, absolutely. That's my understanding too. He just says it point blank.
Yeah.
Or electromagnetic retardation. You know, we can
Okay, shall we
go
march on?
both ways.
Yes, sir.
Yes, sir.
Okay, I
My
think I went over
personal
these,
favorite
but I'll do
explanation.
it again. The MMX found the null speed of Earth through ether.
Is it just because it has the word retardation in it, and and
Dude, it's
like
no
big-
more than 49% because of that.
Yeah, agreed. So let's see here. Michelson-Morley dynamics.
Well, no, it doesn't. Quite a few things wrong, and you should have known because these are all experiments that I went over. Now let's quickly.
All right, then he gets into the general theory, bangs that out, and dude. So Shane, it was really vindicating for this part, dude, because all of everything that he puts forward was like arguments that I figured out from how math
Right.
met your reality, and to hear it from
Right.
a PhD academic, was just like, nice, dude, that's cool.
You mean without reading it in his published paper beforehand to have the preface? Like you didn't know that he had conceived it like this, right?
Yeah, no. I've never read any of his stuff on this.
Right.
or, like,
Okay. Yeah.
No.
Instantly vindicating and very satisfying. Like
Yeah, exactly.
sweet.
Yeah. So definitely check this part out because it's basically a 30-minute condensed version of how your math met reality, but like, just like done in 30 minutes. So let's see. He goes over that, and then the Eddington stuff. So the Eddington plate, kind of goes over the narrative.
Oh, it
and
was such a good
specifics.
Eddington breakdown.
Dude, I know. I was hoping to jump in and do a little Eddington stuff, but we were like pressed for time and all that, But I wanted to read the inverse proportional prediction and stuff because like that's hilarious that it was in the wrong. Like the distance wouldn't even be possible. It only exists through a mathematical correction provided by Frank Dyson Watson, the mathematical fixer for the Royal Society. Your boy coming in with that statistical anomaly. So that's cool. That was nice of him to do that. Shout out to Frank Dyson Watson. And let's see here. There was the Sagnac effect, and then he goes into, I think he covers DeFore and Pruner and Wang. I think we should probably wrap up on that. Do you just let this play out because these are super significant, and then like that's where it wraps up. And
yeah, it seems good.
Yeah, we'll call it a night on that.
Linearization is important.
Yeah.
You have the light source, and we've seen this before, split two half beams go in opposite directions. If the speed is different, you'll have an interference pattern, and you'll detect it here at the detector. Okay? So this is like putting the interferometer on a turntable, okay? And asking, what difference in speed, if any, will I see in the interference pattern with the situation? Well, what does special relativity say? The speed in all these paths is c. So the speed will be c. It will not be affected by the speed of rotation of the disk. What does ether theory say? The ether theory says that the rotating mass of the disk will cause the ether around it to rotate. And so you will have a change in the speed of light, c plus or minus v. This is a vector addition. Now remember what we're saying is basically when you stir coffee with a spoon, you're using a mass to stir up a liquid. Well, suppose you couldn't see the coffee, okay? It would still rotate. Well, that's like here. You can't see the ether, but you can see the rotating mass. You can see the spoon, and in this case, you can see the coffee, but you don't. You can see the coffee, but in this case what's causing the rotation of the coffee. Okay, here's the experiment. Send down a signal in both directions. So what's the reason for splitting the beam? So that they start at the same time. Okay, the big problem would be why not have two lasers, right, sending in different directions? Well, there's no way you could tell when the two light waves started off exactly.
What are you
Because
clicking on
remember,
other stuff,
they have
Alan?
periodic variations.
No,
So the
I'm
phase-
loading something up for additional
Oh.
context at the end about the Sagnac effect, inertial frames, and
It's like,
relativity,
what?
because it's
All right,
all
let's-
related to this towards the end here. I think he touches on it, but I just wanted to provide the Einstein quotes because it's always nice to have the receipts.
That's acceptable
Phase
for
would
the
be
black
different.
screen wood.
But if you split one beam into two, you know that they're both in the same phase. And then they go around. If the disk is not spinning, then they will go equal distance and they will arrive at the opposite diameter. What if they are moving? What if the disk is rotating clockwise? Then the red path will get a boost from the dragged ether on the circumference of the disk, and it will be able to travel further than the blue line, which is bucking the flow of ether. It's going against the dragged ether. And so there will be a shift in the position, and you can measure that with the interferometer. So that's the Sagnac test. How did he interpret it? He said there must be a whirlpool, he called it, a vortex of ether that surrounds the disk when it's rotating, and that is what's causing the effect. What does special relativity say? Well, all kinds of meaningless explanations. I won't even go into it.
All kinds of meaningless
Bro,
nonsense.
the
It's
speed of
not
light.
even worth saying it.
Bro,
I'm trying to
so
squeeze that into the short.
dude,
That's
so
fucking perfect.
So I'll go into them real quick. So up to and including things like saying that the rotation of the device generates little pockets of time dilation and length contraction, which
Personal favorite.
can only be explained from a specific coordinate system where you're at the center of the device, where you could say that that's stationary, non-rotating kind of thing, and then extrapolate out from there. Let's see, and then so the metric tensor that's used to even derive that in general relativity is a first order intrinsic invariant differential, meaning it's just like a mathematical reification fallacy. But they had to like have something there so people could calculate and account for the conservation laws. Otherwise nobody would accept the framework. So they just like slid that one under the rug. So like they literally account for this effect. They scoop it up as a relativistic effect through the general theory. By a literal like logic fallacy in the math, right? So like when you do a dimensional analysis on the tensor and you contract it, it's not applicable to the system because it's not actually part of the system. It's just some shit that they put in, like it's like an additional subset to the system. I can link a video on it by Stephen Crothers who breaks it down really well. But that's the situation with that. So like just to explain this effect, and keep in mind. That's the explanation for the general theory. A year prior to that, and then it took 8 years for them to come up with an answer for this. And the other explanation for the special theory that they have, because as we're going to find out, a uniformly rotating device is an inertial frame according to Einstein, especially if it's a closed loop circuit. So you're good to go on that. So relativity should definitely apply. So it took 7 years for this one to come out. And it's basically just an observer at the center of the device, with a stationary frame. But they swear that you can calculate it from any frame. But as we're going to find out with the foreign pruner, that's not true. So GG.
Nice. So those are all. So to recap, those are all the relativistic adaptations of the meaningless explanation with no basis in reality.
No, that's not all of them. That's only two. That's the two mainstream broad stroke ones that you'll find with ease. There's actually like 8 more that are just like perpetually more ridiculous.
Okay, hold on. Are they more or less ridiculous than tiny pockets of time dilation?
Nah, I guess not.
That is by far my favorite.
Dude, yeah, because at least that one sounds consistent with the general theory, right?
This effect should not be possible. Dufour and Prunier in 1942, they decided to redo the experiment with.
What's up?
Am I watching the wrong thing? I lost audio on the video.
Oh, okay.
Fine with me.
Okay, go ahead then.
More precision, and they got the same result. The speed of light is c plus v, where v is the rim speed of the disk. This is independent of the light source and interferometer. Well, what does that mean? Well, here they show everything is on the disk, but what if you put the light source over here on the lab, put it over on the lab, and then you use mirrors to reflect onto the disk? Would you see a difference? No. So they tested whether moving the light source off the disk makes a difference. What if you change some of the paths here so that they're off the disk?
I mean, really,
okay,
I'm asking that
still the same. And that would be explained by the fact that ether surrounds all of the disk when it's rotating. So whether you put the interferometer off the disk or whether you move the detector off the disk, it doesn't matter. They're all being surrounded
Well,
by
we're all
an
watching
invisible
the live stream.
whirlpool of ether. Now, they also proved that if the light beam goes radially, which means it's going across the ether flow, then there's no effect. And that's what we would expect, because the ether is neither boosting nor slowing the light, because it's going perpendicular to it.
Wow.
Let's see.
Yeah.
There we go.
Yeah, man. So
He
go ahead.
didn't even get into the linearization yet. He was setting it up. That was a hell of a setup.
Yeah.
Mm-hmm. It's a great explanation.
Okay. The text that I copied here from Dufour and Prunier, I'm not going to read that. The reason I put it here is, you see, they mention ether. So they definitely believed in ether. You see it here in red, ether wind here, ether, luminiferous ether. So they definitely believed, and so did Sagnac. He said it was a whirlpool of ether that was causing the effect. And these two guys said the same thing. The interesting thing of this diagram is they decided to ask, what if the light beam goes above the disk? Okay, everything was on the disk for all these experiments. Well, what if you deflect the light beam with mirrors so it's a certain height above? Unfortunately, they only used 10 centimeters, which is 4 inches. But if they used it higher, you could answer the question, how far from the disk will this ether wind
Alan's
persist?
virtual camera is not passing the audio through.
No, it should be on the screen share.
Yeah, it's on the share.
Yeah, adjust the volume on your live stream if you need to, if you can't hear it.
You just click on the
You
live
can right click. Yeah.
It must drop off, otherwise the whole world would be
What's up? You good?
We're good.
I think he's good now, yeah.
Okay.
subject to the ether wind whenever anything rotated. So that's an important experiment, and as far as I know, it hasn't been done. I asked Ru Yang Wang to modify his experiment to do it, but he didn't want to. Now, the Wang test answers the question that the special relativists say.
So real quick, just to recap on this is like a view without the full setup. Let me pull up the paper. Or yeah, you can see it on the webcam, right?
Yep.
Cool.
We can switch real quick because you already have that pulled up. All right.
So this is what they had going on right here. They got the lab wall right here in the background. They had the source and a recorder fixed to the lab wall. They had a stationary top plate here with reflective mirrors with 45-degree angles to hit this bottom plate or this bottom disc here that rotated. Now they're not connected or whatever, so this is a stationary situation up here that reflects back to the wall, and then there's a rotating platform underneath it that turns at 1 turn per second. And what they found was that there's a fringe shift pattern transferred from the rotating plate to the stationary observer, so that there's no ambiguity of like, oh, is it an inertial frame? Is it rotating? Like who's the baby daddy or whatever? Well, these guys are fixed to the wall, so it's definitely an inertial frame. So what they found is there's a fringe shift pattern that has a first order dependence on the rotation of 1 rotation per second, and dependent on the diameter of the device or the area of the device. So very cool stuff. So this is what they were working with here. And what he was saying was it would be cooler if they did it again and increase the height so that you could see like where's the drop off for the translation of motion to kind of map that out. Because at what was it, 10 centimeters or 4 inches, it's you get the full translation with the first order dependence. So
that'd be super interesting to find out.
Right. Dude, we got to get our boy.
And of course, they don't want to get into that.
No, dude, because it's so bad. Because what happened here is the relativity fixer, your boy Paul Lavue, who used this special metric tensor that he came up with to for general relativity, so that he could scoop up the Sagnac effect. He came in to try and answer this and was like, well, you know what they say, boys, if a frame's rotating, you got to put him in the center of the device, because relativity couldn't derive the effects based on the observer's location, because you know how they say all frames are equally valid. Well, relativity could only make the prediction from the center of the rotating disk. If it tried to do it from the wall or whatever, it couldn't do it. So it's like GG.
It's GG on everything relating to us detecting motion, basically.
Yeah. Yep. And then yeah, so the
It's
prediction
only
here,
ever been this. Yep.
yeah, and the relativity prediction was 10x off, and then so his only Paul LeVoux's only explanation was, hey man, you know the rules. If it's rotating, you got to be in the center. And that's not an answer for those listening at home. That's a not answer, and then like you just pretend
Well, no,
like it never happened.
Dude, the only proper answer was the people who thought that the Earth was a globe with heliocentrics who measured it at the time, right? They didn't deduce we've actually gone to detect Earth's full velocity, but actually we detected Earth's motional spin. No, they said, oh, Earth must be orbiting much, much, much slower than we actually anticipated.
What?
Didn't they say that, right? Like when they went to Michelson-Morley, when they measured, looking for their motion measurements, and they got not what they wanted from their fringe pattern, they got a much lower result. They didn't say, we tried to measure.
Oh yeah. They interpreted it as the ether translation of motion falling off at like a different rate. Sorry, I see what you're saying. It was
No, I
kind
think he's saying that they try to interpret it as a much slower orbit, a much slower orbit to match that, but it wouldn't work, right? At first.
Yeah. Well, that's like the stupid position, right? Like that's what people today say about it. They say, "Oh, actually, no, they weren't trying to detect Earth's motion." No, never mind. I just coughed myself stupid. Never mind. I'm done.
I think that you said that, Alan. I think I remember you saying that at first they tried to make it like what the French shift they got is actually just a much slower orbit.
Yeah.
Alan?
What's that? 1 second. Looking at something. Yeah. Sorry, what were you saying? I got totally sidetracked, bro. My bad. GG.
At first, the French shift they did detect, they were going to just interpret it. They were just going to interpret it as a much slower orbit.
Yeah, Miller said something. Or no. Yeah. In Michelson-Morley, it says if we accept the measurements as they are, then it would mean that the Earth is orbiting the sun, but just at a much lower velocity than what we had expected. Yeah.
That's what I was referring to, right?
Yeah.
But that's the only correctly scientific position you could hold with those results, right? Because the people who ran it got something they didn't expect, and they went, "Oh, well, this is the only possible realistic interpretation," which is that it's a much slower velocity. People today went, "Nah, you know what they were looking for? You know what they measured? Earth spin." Well, no, that's not what they thought. Whatever, it's fine.
Yeah. But yeah, so relativity.
We're spinning. We really are.
Yeah, relativity really shit the bed on this one, so it was not answered and just swept under the rug. Very cool. So we'll let Robert play out Wang's experiment.
Now the Wang test answers the question that the special relativists say. They say the Sagnac test does not apply to special relativity because it's motion in a circle. And they say that Einstein's theory only applies to straight line motion. Well, Einstein himself denied that. He said, suppose you take, say, a triangle, and then you send a light beam around the three sides, and you neglect the time that it takes for it to change direction at each vertex. And then suppose you include the number, you increase the number of sides. In fact, you increase it in a calculus sense that you will let the number of polygon sides approach infinity. Well, then you have a circle. The polygon becomes a circle when all of the sides become infinite.
So a closed polygonal circuit. So any closed polygonal circuit that's in uniform rotation, as quoted by Einstein here, I pulled it up on the webcam. I'll give you the screenshot, Shane, so you can incorporate it into your business folder. Very cool. Yeah, so here he's saying his equations hold true, or in any frame that Newton's equations hold true, and that's for the inertial frame. And then he goes on to say, also any closed polygonal circuit that's in uniform motion, the equations hold true as well. So
he dunks on it by saying, actually, it doesn't discount circular motion. That's not a relativistic effect. Before he dunks on it by saying, actually, it plays no part because it's linearized. Wow.
Yeah, and so that's why Sagnac's paper. So it's like specifically titled. Let's see, Sagnac, my boy. So the existence of the luminiferous ether demonstrated by means by me, or the luminiferous ether detected as a wind effect relative to the ether using a uniformly rotating interferometer. Like that's why he was like, hey, I just debunked your thing, and he was like winning awards in France because he just body bagged relativity theory, because guy that made the theory explicitly said, hey, by the way, any closed polygonal circuit that's rotating in a uniform motion, like we're good to go. I can rock with that. It turns out they can't. So that's unfortunate for relativity. And
No, those special relativists. You
oh,
mean.
sorry, that's the special relativists. So yeah, unlucky,
And he said, so special relativity can be considered as a infinite-sided polygon. And
yeah, and then so Wang was like, oh, no worries, bro, I got you. We'll just linearize it and then make it an inertial frame anyway, according to your standards.
It applies. So even Einstein said that special relativity applies to circular motion. Anyway, Wang proved it anyway.
Right.
He set up.
He ducks on it. He ducks on it like
Here's the
every which way.
interferometer. It's riding on a air glider, which he calls a conveyor. The air glider eliminates all of the friction. So when this moves horizontally, there's virtually no friction or rubbing between the cart and the conveyor. There is a.
Oh, dude! I didn't even know that detail. This is such an extensive body bag. Because what's his name? I forget who said it. It was Mr. Grimm who had some points of contention in regards to friction with this setup, and I didn't realize that this was a air conveyor belt where there's not going to be any. Like, dude, that GG.
Little detail, yeah.
Fantastic. Fantastic.
That is crazy.
Optic cable carrying the light, and it goes in both directions, opposite directions. Again, we have the beam split into two half beams, the usual routine. If there's a difference in the speed in this direction versus this direction, but this time we know the speed of the ether, it's the speed of the conveyor, then you'll see a interference pattern. And he did. It shows as you speed up the conveyor, the phase difference changes. So this is simply measuring the speed of the conveyor mechanically, and this is measuring the speed of the conveyor optically. And it's almost a perfect straight line. So what he's...
Yep.
So real quick, this entire mechanism here is a fiber optic cable that's connected to...
Right.
What are they
So
called?
it's not like
Yeah.
a fucking conveyor belt attached to a spring rotating around a thing like a tank tread, where that's what Grimm was saying, like, well, there's friction that you would have to account for. In there.
Yeah, so just the motion within the fiber optic cable between the two wheels here gets the full effect of the of that rotation. And then rotation. And then this linear fiber optic gyro that's attached.
Not yet. Hold on.
Yeah, go ahead.
Oh, hey guys. This is Andrew. I'm on the phone with Skylar right now. You guys want to have a little chat?
Yeah.
Yeah, we do.
What's
Yeah,
up?
we do.
He's live on stream. Do I need to mute?
Yo, yeah.
Oh, no,
let me
I'm on my
I'm
phone,
gonna
so I have
pause
to put him on
live stream.
speakerphone.
Yeah,
Okay.
probably not live stream. Pause.
All right, hold on.
Thanks everyone for listening.
He's in prison. He can't say anything too crazy. It's all recorded. We're good.
Hey, should I do the Michael Brenner thing yet or no?
Not right now. No. We gotta talk to Tribune.
Yeah.
Okay,
All right. Here's Skylar. He's right next to my microphone right now.
What's up, dude?
Yo, what's up, buddy? We miss you.
I can barely hear you guys because of the medium suck, but definitely missing the Discord ragers. Alan, good job on absolutely shredding Nicktoon. See that?
Yeah, thank you, bro.
Nice.
Prison sucks.
Dude, I heard you were flat smacking inmates all around.
I'm staging a tremendous comeback, so can't wait to get back in the arena and do some shit.
Nice.
Nice. Awesome, man. Looking forward to your return, bro.
Still barely hear you. I apologize.
No, it's my speakers. The microphone and the speakers are a little too far apart from each other. So
We're all thinking about you, dude.
Yeah, everyone in YouTube
For
chat
real.
wishes you the best too, bro.
Big time.
Yeah, I appreciate it. If you guys really want to help out, then just keep your mental energies knowing the fact that I will be out very soon.
Nice,
Nice,
dude.
like, dig it. I'm with it.
Going good, bro. What's
I bet
up?
you're using using your time to study up in there, I imagine too, right? Lots of time to read and stuff.
Yeah, I'm doing a ton of reading, and I'm going to be getting some. I'm going to be getting some flat Earth friendly books here.
Nice.
Nice.
My boy Andrew, so that's going to be cool.
That's what's up.
We were
Yeah, no-
in the middle of a live stream. Sorry for that was a great for Andrew to come on and get you on that. I don't
That
know if you
was
guys
awesome.
paused the live stream or if you ended it or what. But
No,
Like the best thing.
No, I'm still
No,
streaming.
we're good. We're still going. Yeah.
Yeah, that's
Dude, we
cool.
all wanted to hear from him.
Yeah,
we all been
that's-
asking,
yeah, dude, that's
like, what the fuck's going on with him, and now here he is.
Praying to hear his voice.
Right.
Like,
Yeah, he knew he was live.
Thanks for doing that.
I think Andrew just
Alright,
was
well, I'm
like,
gonna-
"Yeah, you're good. Thanks, man. Appreciate it."
Yeah, no problem. I'm gonna get back to talking to him.
Yep,
All right.
So hang in
Yeah.
there, bro.
that's what's up.
Dude, I knew
Yeah.
he'd be flat smacking the inmates.
Dude,
trying to
absolutely.
add Samuel Robotham to the inmate fucking library. Like, dude, you guys don't have like the books in here. Hold on, can I put in a request? Who do I gotta?
Dude, he's like the
He's gonna-
Shawshank Redemption guy. He's writing Congress every week. Like, yo, dog, what you know about zetetic astronomy? My boy Samuel
Dude, he's
Robotham.
converted like his whole block. Definitely, his cellmate is now a flat Earth, and they're like little like preachers. I
He's got his own
can
flat
see it
Earth
already.
gang. They're going around like
I can see it, man.
flat
I can
smacking
see it.
people and shit. Like, dude, that guy's tough, man. He's like a flat Earth bully, man.
Because you know what I was thinking? It'd be really easy to flat smack inmates because like their scientific knowledge, you could probably like just destroy them.
and
No,
most of them don't trust the system.
right? So it's a good combination to like try to get some converted.
Yeah. Find God too.
Yep, absolutely. All right, we'll go ahead and play
Proving
this
is
out real
basically
quick.
the same as Sonyak did, except he's overcoming the objections that it's only applicable to linear, because obviously it is. Okay, we went over this, and this is just a schematic of the of this setup. All right, here are the results. The speed is 0, and the speed of light is c in all frames. But for when v is greater than 0, that is when the conveyor is actually moving. This is when the conveyor is at rest. Then the speed of light is c plus the speed of the dragged ether from the conveyor. In other words, you have to go from the lab frame of reference to the lab plus ether frame of reference in order to correctly predict what the speed of light will be. This is just a graphic representation of c plus v.
Dude, how cool is it to know that when you're in motion or anything's in motion, there's a literal ether vortex following you? How does that make you feel, boys? And the vortex will be proportional to your velocity.
It makes me feel uplifted, Alan.
Dude,
yeah, it
it's
sounds creepy, but it's actually
it's badass, dude. It's badass.
Yeah.
Now, what you could do with the Wang test is map the Earth ether. You could use this linear test to find out at different altitudes and at different locations on Earth, what is the change, what is the speed of ether, and how does it change with time? In other words, you could do the same as you do with geography, a topographic map. You could, in fact, that's what the Russians are doing. You can map how the ether changes across the surface of the Earth with time. And you could do it in space too. You could do it on the International Space Station, or if they go to the moon and they take the equipment, the Wang equipment, they could measure the ether around the moon and see if it's what is predicted.
We'll allow you that
Galileo ship is
boomerism without
famous.
comment.
In his writings, he said, if a ship is docked and you're below deck, you can't tell if you're moving. The same thing if you're moving in a straight line in calm sea, so the boat isn't rocking, and you're below deck, so you can't look at the shore and see if you're moving. Then Galileo claims that according to the law of inertia, which is what he proposed before Newton, that you will not be able to tell whether you're at rest or you're moving at constant speed. Now, Wang found that the speed of the ether could be measured in the hold of the ship. So all Galileo had to do was take the Wang linear test in the hold of the ship, and he would be able to detect when the ship is actually moving, because the ether would be moving if the ship is actually moving through the water, and it would not be moving if it's at the dock. Now here are the summary of the Wang test. What he found was, well, actually, Dufour and Prunier found this, and I asked Wang to do this, but he didn't want to do it because apparently he was under pressure not to
He's
do.
afraid of the
these experiments
implications.
anymore.
He said that quite plainly. Yes.
Yeah, man. I'm glad that he touched on that because,
Yep.
like, that's like, oh, where's your Nobel Prize? Yeah, dude. What happens when you try to get Nobeled up, dog? You get pressured. You get your career threatened. You get told you can't have access to $5 million gyroscopes to do experiments with.
Yeah, you get defunded.
you
Your
get-
labs don't get money. You can't do experiments. You get decredited. You can't get a job.
You can't get your papers published.
Yep.
You know, no.
Yeah,
Sorry,
literally they
dude.
destroy you. So that's why no one goes against the grain very hard, except for old retired G's like this guy.
Look at how, yeah, dude, you literally have to catch someone on their retirement on their way out. That's like, hey, by the way, did you guys know that they laid coaxial cables down in like 1992 and realized that there's a preferred direction
But
in the
he's
speed
old
of
enough to
light?
not give a fuck. Like he's fought in
dude.
public and he at the gym. Like this is the guy. Like he's gonna tell you what he thinks.
Like, dude, it's so, yeah, man. Like, you know, God bless, right? So yeah, we're almost done with this, and we'll wrap up.
In the lab, he measured the speed of the light to be c plus v. When he put the detector on the conveyor, he also found c plus v. All right, what does special relativity say about these results? Well, it says that the speed of light should always be c. So both of these results.
Yo, is it showing? Are you guys getting the audio?
Yep.
I am, yeah.
Okay, cool. I just wanted to make sure.
We would have complained before now.
Okay, I was reading Invisible Man's message. It says that he was having trouble getting it. Are you watching the webcam feed or are you watching the live stream feed? Because I got them both going because I was changing between different stuff.
And I had to unmute it before, but I have it unmuted now and it's not playing, but it's no big deal.
I got it paused right now, so I wanted to make sure you were straight.
Contradict special relativity. Postulate
All
2.
right,
Speed of light is not constant, even if you do this in a vacuum. It was done in air, but it was repeated in a vacuum, and you get the same results. Now, what about dynamics? That is, using the laws of physics to predict what the speed of light would be. Well, if you're on a moving conveyor, and you know that in the lab the speed of light is c, then you know that if the ether is moving at v, then the total speed is c plus v, and that is what's measured. In the dynamics, though, we would predict that this is c, and actually the conveyor measures c plus v. Now, see if you can follow this. If you were shooting a gun and it on the ground, and the muzzle velocity was 1,000 feet per second, then you go on a train, and the train is moving at 10 feet per second. Then you would add the two together to get the speed of the bullet measured from the ground. But what if you go onto the train and you fire the gun? Well, then the speed of the muzzle velocity should be 1,000 feet per second because you're on the train, so the speed was measured with respect to the ground. That's not what this predicts. This predicts that the speed of light plus v, speed of light plus v is what's measured. So this is the true value, and this is what's predicted. So not only is postulate 1 wrong, but using the conveyor as a reference frame is incorrect. And that's what I'll show in part 2, is that this experiment is very important, not only for showing that special relativity is invalid, but it shows that the reference frame is important. We get the correct results in the lab, but we do not get the predicted results using Galilean dynamics if we are in the conveyor. So the conveyor frame is invalid for dynamics. Okay, that's a mystery that I'll have to try and resolve in part 2. So the purpose of all this was to expose you to.
So I'm going to skip ahead real quick because I actually got him to touch on it real quick because that's like super pivotal to the whole thing. So let me skip ahead to where I get that out of him before he dips.
The frame in motion isn't the valid.
Well, enough for me for today, and I look forward to any questions you have, or maybe we could take a peek at part 2 just to see what's going to be.
Yeah, to show us what's around the bend. Yeah, because what you were about to touch on with the dynamics and how the frame in motion isn't the valid frame is going to become super significant to the arguments at hand when we're dealing with interferometry and distinguishing between is the Earth truly in motion or is it stationary? Like this is a big defining factor here, and this is what is what's going to separate it. And so we often say things like there's physics in academia is compartmentalized and all these things, and we're like we're just kind of laughed at about that. But it's like this is the distinction right here. This is exactly where the kinematic and dynamics are going to divide the distinction between the two models. And we're going to have a complete falsification of one model in a mathematical theory and a verification of another one out of this. So,
yes, I totally agree, and I think it's going to be very hard for some people to accept. But yes, there are preferred frames of reference. There are frames of reference in which the laws of physics are valid, which are inertial frames.
He's
and
on
there
board.
Are other frames in which they are not valid. And even Newton
Dude, he's like 99% where we're at. He's just old and stubborn.
Yeah. Yeah, that's why
Yeah.
it's like whatever. And plus,
He's there, dude. He's there already. I feel it.
yeah, dude's
You
a
won't even
champion.
take like a slight breath of wind to push him over and lean over here now.
He's like, oh, curved visual space, hyperbolic geometry. Oh, no way. Okay, cool. I guess that's a wrap.
Nice.
Like that's all
Yeah,
he's good.
definitely.
That's all he's
So-
gonna need. And,
so-
and a little sunset from Shane sprinkled on top with southern stars.
So wait. So his belief then, to assume, is a spherical Earth at the center of everything, created by God, with a rotating ether toroidal wind rotating around him. Is that what he thinks is going on?
So the universe rotating around the Earth, yeah, essentially.
Yeah. So like, but
Around
like
the
a
stationary
spherical
orbit,
Earth at the center of everything.
Yeah.
That's much harder to believe than what we believe, isn't it?
I mean, but it's like socially
I don't know.
acceptable because it's still globular.
Oh
and
yeah,
shit.
yeah, yeah. Forget
But
about
you
that.
gotta
That's
think
so
of
easy
the-
to forget. Yeah.
Yeah, and
You're
actually,
right.
Still cling to your ball.
yeah, and actually,
Like at least he's taking the motion away from it, you know? Like at least it's a start.
yeah.
No. The socially acceptable part was nailing it on the head. Because I disregard that completely when you don't give a fuck anymore, right? Like all of us. I forgot that was a component for like public facing, like reputable people. Obviously, it's a very big component. I totally forgot about it. Sorry.
Yeah. Yep.
Experiment. He found out that the laws of physics, his laws, do not always apply. And the question is why? And we'll try to answer that both too.
Awesome.
So you want me to just skim over what I'll cover, or?
Sure. Yeah.
Okay.
Yep.
Okay, I'm going to introduce a model that actually is 8 centuries old. I was introduced to it, and I'll find.
All right.
Now, this model agrees almost totally with all of my research. It's called the Hildegard model, and it includes ether winds. I'll discuss an ether gravity model, which uses some of what Agavatsky discovered and what the other Russians have found to try and define what ether gravity is. And I'll use the Hildegard model. We'll discuss how does the geostationary orbit, how is it explained?
All right, cool. And yeah, he goes over some other stuff there at the end, but yeah, so basically the situation with Wang and all reference frames being equally valid, and how it was
Yeah.
how
Dude, so
everything
he knows the significance of that. He knows that Wang knows it too, and he knows that Wang backed off because of pressure because he knows.
Yep. Because we are super stationary, dog. And if you
Yeah.
start continuing out these experiments, it will become
Yeah, if you extrapolate anything further,
yeah, it will
you're in
become
trouble.
super obvious that it's a GG. I mean, imagine if we had like access to do the deform pruner setup. Like, oh man, like that would be insane, and like increase the height and stuff and see what we can
Yep.
come up with. Like,
Corroborate everything that we said, corroborate what Bob measured, corroborate his work, his published work. Dude, it's so funny that he believes he's found almost all the truth. I'm curious, like, what he would think about the scamdemic and like JFK and 9/11 and stuff.
well, hold on, I'm still streaming on YouTube. But yeah, it would be interesting.
Yeah, that was just a passing musing. Like,
Yeah, no, I got you.
wonder what he thinks.
Well, I just didn't want anyone else to be like, oh, by the
Throw-
way, I
just
wonder
throw
what he thinks
right
about.
words in there.
Yeah, just a friendly reminder. So yeah, and there was this thing at the beginning, Shane. So you know how they tell us that our sun is actually like a baby sun, or it's smaller than all the others.
Yeah,
stars.
younger than all the other ones, and it's
So-
lasting for 100 million.
So
whatever
get
the
this,
fuck, yeah.
dog. The spectral shift that they get when they look at the sun is unique from all the other stars. All the other stars vary.
Our
They're-
star is a
it-
special star? No way.
dude. So how could they make the justification that all the other things that we see in the sky are little tiny dots are actually giant super suns that are way bigger than our sun? But if the spectral shifts don't even match from like the way that they say that the sun works and all that stuff, it produces a specific signature, and that spectrum doesn't match for what they say that the stars are. So like how they justify it as an actual star is crazy. What's up?
Yep.
What do you think about the stars being electrostatic condensates, like just a little ball of electricity that's basically trapped, at a constructive interference point? Because then you could actually apply Newton's law of gravity, since it mimics Coulomb's law, and it would actually describe the force between the point charges.
Well, it's funny you mentioned that because the with the mass not even being the actual factor, and it's just a description of the inverse relationship with it.
Oh,
I
dude.
kind of like what you're saying there. Like,
So yeah, let's combine
So
the negation of the inclusion of mass for the dynamic equivalence breakdown for the kinematics for the geocentric kinematics, whatever the fuck you said. Let's compare that with the fucking inverse relationship that mass plays to Coulomb's law and Newton's law of gravitation, right? G equals m1 over and m2 over q, I think, or whatever the fuck.
yeah,
There it is, right there.
I'm about to pull them up.
So yeah. So if mass doesn't matter in the kinematic of breakdown, and mass matters for everything between the differentiation between Coulomb's law of electrostatics and Newton's law of gravitation, then what can we extrapolate about mass? I don't know.
Think about it, it's like the geocentric model, and the heliocentric model can be mimicked by the thing that whatever that paper was that Whitsitt was talking about last night, the relationship between what is it, where both of them are described by the same thing, basically.
It's a kinematic equivalence, meaning that they can mathematically describe them symmetrically perfectly. Yeah.
Kinematic equivalent. That's exactly what you have right here, except you're just replacing mass with the point charges.
Well, yeah, but the significance of actually, when you come down to it, mass is nothing. It cancels out from both sides of the equation when they do the breakdown, meaning that it's like statistically irrelevant. And they were like, "Oh, it's everything." Well, no, it's nothing, because you can remove it completely and nothing changes. So, like, what do we say about that relationship when you say the only thing separating the law of electrostatic force and the law of gravitation is an inverse relationship to mass?
Because if you think about it, if you think about what Polaris is as a vortex point in a toroidal field, then what are the rest of the things going to be? They're going to be basically a mimicry of that, because it's just going to be constructive interference points along that toroidal field array, along the construct.
So Shane, I forget, Fractal Woman has a video on it, but basically two vortexes that are spinning the same direction will, I think they join, or like, they attract.
They'll
So
repel, I think, right? Isn't it? Two in the same motion repel.
You would think, but it was like it blew
Oh,
me
it's
away
the
because
opposite of opposites
it's the
attract. Yeah.
yeah. So it's like, so we're dealing with vortex situations here with all this. So it's like just two vortexes, in an inverse relationship between those two vortexes.
Are you talking about toroidal versus poloidal fields? Like where they combine toroidal and poloidal, where they were? That's one of the.
I think he's talking just about the motion.
Yeah, just
So,
talking about the motion and the speed of the vortex.
So when you guys were talking about like mass, right? Like Coulomb's law deals with charge, right? And then they replace charge with mass when it comes to the universal law of gravitation. Everything else is basically the same. You just have a different constant that's moved in there, and then you throw in the radius of the Earth or the distance, I guess it would be the same. So my understanding, I always boil mass down to what is mass at its essence. And I go to atomic mass, and then when I look at the periodic table, but I look at it the way that Walter Russell lays it out, makes perfect sense to me. You have this, I guess you could say, harmonious flow in a sine wave pattern within the periodic table of elements based on vibration. But then the breaking down of the atomic mass, if they're calling protons, neutrons, and electrons, and they define those as like positive and negative charge and a neutral charge, however you want to describe those, a charge and a discharge and a equilibrium. That's how it's all broken down. So effectively, I look at the universal law of gravitation as Coulomb's law, just in a different octave or a different vibratory spectrum, in the same way that you would look at like something being coherent and incoherent when it comes to magnetism.
Ooh.
So I look at Coulomb's law as like a coherent electrostatic acceleration towards a null pressure point, and then the universal law of gravitation as like an incoherent
So
acceleration.
What a
yeah.
fantastic fucking
Dude.
contribution. Thank you.
So it's describing the pressure mediation between two things with an inverse proportional relationship.
Yeah, and based on the essence of that thing, it's basically what Newton was alluding to with mass, and mass attracting mass is some sort of weird thing that seems to be inherent to material. Well, if material structure is only able to be coalesced into reality based on these electrostatic bonds within the molecular and intermolecular structure of everything, would it make sense that overall you have this incoherency in which you have this relationship within the overall medium within the realm?
Well, dude, it's funny you mentioned that, because you know the thing that was removed from Newton's Principe or whatever, his Grand Master work or whatever, number 46, was his thoughts on the ether and how it actually worked. And so he basically was describing a pressure mediation system, and like, yeah, if you just replace that concept with like a mass attracting mass with those equations, now that we know that it's purely kinematic, I mean, it's literally just describing pressure mediation between two systems using a constant that they that they can use, that they can scale invariantly once they have once they just have a constant to work with.
Dude, I wonder if that guy Bennett, when he said static gravitation, the force of gravitation is just static ether or ethereal static. I wonder if he reckoned like used the word static as like still, not in motion, or static to represent electromagnetic, electrostatic forces.
Gonna have to ask him.
Yeah, because it would be like a sweet little nod if he did it the way that we would use it.
Yeah,
he knows it would tie in like that, like a little part 2 lead in or something.
Yeah, dude.
That would be dope.
No, he gave a big part 2 lead in.
Yeah.
He was so pumped to share.
I love the way he did the static, ethereal static, or was it static ether? That's what gravity is, just static ether. Oh, I caught a little static ether today, guys. It brought me down a little.
Yeah,
because
pretty interesting.
It's exactly inverse to the ether wind, right? The etheric wind that goes all the time. What's the force that pulls you down? Oh, well, just the static ether. That's ethereal static. Oh, yeah, that makes sense.
Man, that's fascinating, dude. So,
although personally, I love the etheric tides of today. That's my favorite part.
Yeah, ether tides.
Yeah, dude, the tides were sick. This is gonna like lead to such cool things.
Yeah, absolutely, dude.
I can see it already spinning in my head. Like, yeah, dude, Toby, we're all rely on you to clip all these awesome things. Hopefully,
a lot of work to do.
The whole movement depends on you. Don't let us down, bud.
Yeah.
Yo, New Perspective, are you around? I was wondering if you wanted to read that Michael Brenner.
Yeah,
I'm ready.
Yeah, you want to play me?
Yeah, let's close
Off
this out
the
with
stream.
that. Hell yeah.
Yeah, it's interesting to ponder this whole idea of geocentrism being like the compromise to the whole thing, because he's talking about the kinematics and geometry not being the dynamics, which is the real physics of everything. But how does it work with the ball in the middle of the space? It'd be interesting to hear what he has to say about the dynamics, how that works. But Michael Brenner, as you know, I've always brought up this passage, or a couple of them, that he points out that there's a big difference between kinematics, geometry, and dynamics. So I'll read what the beginning of this one says. The question on Quora is, what are the biggest scientific problems, the globe Earth model, or the biggest arguments against it? What are the biggest scientific problems of the globe Earth model, or the biggest arguments against it? He says the biggest problems with all scientific models, as well as the prime source of errors, is the neglecting of the demarcation lines between domains of validity. The result is an endless squabble about true or not true, about verified and observed and predictive, and all these totally fruitless as well as endless battles. Therefore, it should be routine to begin every scientific discussion by agreeing about these domains and their borders in order to immediately understand what part of the argument is limited to what domain? These three domains are geometry, kinematics, and dynamics. Geometry only describes dots, lines, and surfaces and their relative arrangement. Geometry does not include motion, masses, and forces. So to take a geometry and just slap a motion and a mass onto it is a violation of this domain and thus necessarily produces errors. Kinematics adds the concept of motion to dots, lines, and surfaces. But still, there is no consideration whatsoever of masses and forces. So taking a kinematic model and mistaking it for a representation of physical reality is a violation of this domain and can't but produce errors. Geometry and kinematics are branches of mathematics, which is a theoretical domain and not a domain dealing with tangible physical reality. Dynamics then adds the consideration of real-world masses and forces to the theoretical concept of geometry and kinematics, which makes dynamics into a branch of physics. The investigation of the behavior of actual physical bodies. This can no longer be done with pen and paper. This can only be done by way of experiments. The question here is about the problems with the globe Earth model. So let's apply the above domains to the two most fundamental aspects of this model and see how they fare. Rotation and orbit. And then he goes into the whole idea. But then the main thing is when you talk to a glober or anybody about dynamics, what they're ignoring at all costs is the centrifugal force for their orbits. And he goes into a lot of this ridiculousness, calling it a pseudo force and, reference frame dependent and all these things that, are just ways around treating these bodies in motion as if they're forces in physics that have a relation to each other. And if you're just going to say centrifugal force is a pseudo force so we can negate it or cancel it out with centripetal force and act like the water against the back of the bucket isn't the force, but it's the string that pulls the bucket that's the force, only recognizing the centripetal force, which is what they need for their whole, gravity tether theory to somehow be comparable in their minds, even though they may think it works, they may just think, okay, the law is that centrifugal force doesn't exist because it's a pseudo force or whatever. But they have to believe that, even though they know just by common sense that the force is the water against the back of the bucket. And it's just like you against the side of the car or anything else.
Tell them to put the water on the outside of the bucket and demonstrate it.
Exactly. It doesn't work.
You're in third grade.
You wouldn't even have one orbit if you're using dynamics, you wouldn't get one orbit. And I don't know how that would work with ball in the center of everything either, because you're going to definitely have to negate centrifugal force there. So I'd really like to hear what these guys like Bennett or Robert Sangenis have to say about, the centrifugal force not, being negated there. It doesn't make any sense then either. But at least it's a happy medium. And that's interesting that they can still go along with the program to such a degree. It's like a block wall that they still can't get past or something.
They completely ignore centrifugal force.
Oh yeah,
that's a fictitious force. We don't have to talk about it.
They call it a fictitious force.
Yeah. Yeah. Yep. Exactly. Just talk to Zanuck. He'll tell you it's just pseudo force. No big deal. But hey, I got to roll, gentlemen. Good conversation. Appreciate it.
Yeah, and
dude, thanks.
Definitely, thanks for coming, man.
Yeah, you slay it, bro.
DM me to remind me about these things, boys. I appreciate it.
Absolutely.
All right, thanks, guys. See ya.
Yep.
All right. Cool,
definitely DM him for more contributions.
What about Napalm? We love Napalm.
Yeah, he's great.
He's so quiet. Like when he speaks, everyone has to stop.
All right. Thanks for coming out. Hope you guys enjoyed the stream. Got some information out of it. Have a good night.